Imagine a world where planets exist in the most impossible places, right next to a cosmic monster that can devour anything in its path. A place where gravity is so intense that not even light can escape, yet somehow, entire planetary systems might be hiding in the shadows. It sounds like something out of science fiction, but what if I told you that some scientists believe planets could form around black holes? Not only that, but these planets, if they exist, could be some of the strangest, most extreme worlds in the universe. Black holes are known for their ability to pull in everything around them, from gas and dust to entire stars. They warp time, twist space, and have a gravitational pull so strong that once something crosses their event horizon, it's gone forever. Given how destructive they are, the idea of planets forming around them seems almost impossible. But the universe is full of surprises, and some astronomers believe that under the right conditions, planets could not only exist near black holes but actually form around them, just like planets form around stars. To understand how this could happen, we need to rethink what we know about planetary formation. Typically, planets form from the leftover material around a young star. When a star is born, there's usually a swirling disk of gas and dust around it. Over millions of years, tiny particles in that disk stick together, forming larger and larger objects, until they eventually become planets. But black holes aren't stars. They don't shine with their own light, and they don't give off heat in the same way. So if planets were to form around them, the process would have to work differently. One of the biggest clues that planets might exist around black holes comes from something called an accretion disk. When matter falls toward a black hole, it doesn't just plunge straight in. Instead, it spirals around, forming a flat, spinning disk of gas and dust. This disk can be incredibly hot and bright, often outshining entire galaxies. But in some cases, especially around supermassive black holes at the centers of galaxies, the outer edges of these disks can be much cooler. In theory, if enough dust collects in these cooler regions, it could start clumping together, just like in a normal protoplanetary disk around a star. This idea isn't just speculation. Scientists have run computer simulations to see if planets could form in these conditions, and the results suggest that it's possible. In fact, some models suggest that the amount of material in these disks could be enough to form planets much larger than Earth, maybe even planets thousands of times the mass of our planet. These would be unlike any planets we've ever seen, orbiting in total darkness, lit only by the faint glow of the black hole's accretion disk. But if planets can form around black holes, what would they be like? First, they would be in an environment unlike anything in our solar system. Imagine a world where the sky is pitch black, except for a blindingly bright, swirling disk of light stretched across the horizon. The intense gravity of the black hole would warp space so much that if you looked in one direction, you might see light bending around and showing you the back of your own head. Time itself would behave differently. If you lived on one of these planets, time might pass slower compared to someone far away from the black hole. And then there's the question of habitability. Could life exist on these planets? It seems unlikely at first. Black holes don't give off heat the way stars do, so any planet orbiting one wouldn't get warmth in the traditional sense. But the accretion disk itself might provide some heat and light. In some cases, black holes also produce powerful jets of radiation, shooting energy out into space. If a planet were in just the right spot, it might receive just enough energy to support an atmosphere or even liquid water. Another possibility is that these planets could have thick atmospheres trapping heat, similar to Venus in our own solar system. If they had the right chemical conditions, they might even generate their own heat through geological activity, like tidal forces from the black hole's gravity stretching and compressing the planet's core. There's also the question of what would happen to planets that wander too close. The closer a planet is to a black hole, the stronger the gravitational forces become. If a planet gets too close, it could be ripped apart by tidal forces, shredded into a stream of debris that spirals into the black hole. But if it stays in a stable orbit, it could theoretically last for billions of years, just like planets around stars. Could we ever find one of these planets? That's a tricky question. Since black holes don't emit light, any planets orbiting them would be nearly impossible to see directly. However, astronomers have ways of detecting planets without actually seeing them. One method is called the transit method, where a planet passes in front of its host star, blocking some of the light. But since black holes don't shine like stars, this method wouldn't work in the usual way. Instead, scientists would have to look for indirect clues. If a planet orbits a black hole with an accretion disk, its gravity might cause tiny wobbles in the disk structure. It could also create shadows or disruptions in the flow of gas. If astronomers spot patterns in the light coming from a black hole's disk, it could hint that a planet is there. Another method involves gravitational microlensing, where a planet's gravity bends and magnifies the light from distant stars. If a planet happens to be orbiting a black hole and passes in front of a bright background object, we might see a brief, telltale signature of its existence. If we ever do find a planet orbiting a black hole, it would change everything we know about how planets form. It would prove that planetary formation isn't limited to just stars, but can happen in some of the most extreme conditions in the universe. It would also open up new possibilities for where we might find habitable worlds. If planets can exist around black holes, could they also exist in other extreme environments, like around neutron stars, or even free-floating in intergalactic space? And then there's the ultimate question: could intelligent life exist on one of these planets? If life can adapt to extreme conditions, could an advanced civilization develop near a black hole? If they did, they would have access to an incredible source of energy. Some scientists have even speculated that a highly advanced alien civilization might use a black hole as a power source, harnessing the energy from its accretion disk, or even using its gravity to manipulate spacetime for interstellar travel. For now, the idea of planets forming around black holes remains a fascinating mystery. We have some theories, some simulations, and some tantalizing hints, but no direct evidence yet. The search continues, and with new telescopes and advanced technology, we may one day discover that the universe is even stranger than we ever imagined. If planets do exist around black holes, they would challenge many of the assumptions we have about how and where planets can form. Traditionally, we think of planetary systems as forming around stars, with a stable source of light and heat providing the necessary conditions for planets to develop. But if planets can form around black holes, it suggests that planetary formation is far more flexible than we ever imagined. It means that instead of being rare, planetary systems could exist in places we've never even thought to look. One of the biggest questions is what kind of planets would form in such an extreme environment. Would they be rocky like Earth, or would they be gas giants like Jupiter? The answer depends on the conditions within the accretion disk. If the outer regions of the disk have enough solid material, rocky planets could form, just like in a normal planetary system. But if the disk is dominated by gas, then gas giants might be more common. In fact, some scientists believe that these planets could be much larger than anything in our solar system. Since black holes with accretion disks can have an enormous amount of material available, it's possible that planets forming there could grow to be thousands of times the size of Earth. These superplanets could be made of ice, rock, or even exotic materials not found anywhere else. And what about moons? If planets can form around black holes, could those planets have their own moons? It's possible. In our solar system, we see that large planets tend to attract their own satellites. Jupiter and Saturn, for example, have dozens of moons. If a massive planet formed around a black hole, it might be able to capture smaller bodies in its orbit, creating a miniature planetary system within the extreme gravity of the black hole. But the conditions would be unlike anything we've ever seen. The gravity of the black hole would constantly influence everything in its orbit. Moons might have unstable orbits, shifting over time due to the immense gravitational forces at play. Some moons could even be pulled away from their planets and sent spiraling toward the black hole, never to be seen again. Another fascinating possibility is that these planets might not even be made of ordinary matter. Around a black hole, the physics of the universe start to behave strangely. Some theories suggest that exotic particles could form in these environments, creating planets made of materials we've never encountered before. These planets could have strange, unknown properties, perhaps superdense cores, atmospheres of exotic gases, or even surfaces that bend spacetime in bizarre ways. But even if planets can form around black holes, there's one big problem: the extreme radiation in these regions. Accretion disks are incredibly violent places, filled with high-energy radiation that could make it difficult for planets to remain stable. Any planet forming in this environment would have to withstand intense bursts of X-rays and gamma rays, which could strip away its atmosphere or even prevent it from forming in the first place. However, there are ways a planet could survive. One possibility is that it forms far enough away from the black hole that the radiation is less intense. Another possibility is that the planet has a thick atmosphere that protects it from the high-energy environment. Some planets in our own solar system, like Venus, have incredibly dense atmospheres that trap heat and radiation. If a planet around a black hole had a similar atmosphere, it might be able to withstand the extreme conditions. But perhaps the strangest idea of all is the possibility of life on these planets. Could anything survive in such an extreme environment? At first glance, it seems impossible. Without a stable source of light and heat, life as we know it would have a hard time surviving. But some scientists have speculated that under the right conditions, life could find a way. For example, life on Earth doesn't just depend on sunlight. Deep in the ocean, we find entire ecosystems thriving around hydrothermal vents, cracks in the seafloor where heat from the Earth's interior escapes into the water. These vents provide the energy needed for life to survive, completely independent of the sun. If a planet around a black hole had similar geothermal activity, it could provide the necessary conditions for life to exist, even in total darkness. Another possibility is that life could evolve to use the faint glow of the black hole's accretion disk as an energy source. While the light from the disk wouldn't be as steady as a normal star, it might be enough for some types of organisms to adapt. Life on such a planet would be incredibly different from anything we know, perhaps using different biochemistry, or even evolving in ways we can't yet imagine. And what if intelligent life developed on one of these planets? A civilization living near a black hole would experience time differently from the rest of the universe. Because of the way gravity affects time, someone living on a planet close to a black hole would experience time much more slowly compared to someone far away. This means that while only a few years might pass for them, thousands, or even millions of years could pass in the rest of the universe. This leads to some mind-bending possibilities. What if an advanced alien civilization evolved near a black hole, but from our perspective, they appear to be moving incredibly slowly? If we tried to communicate with them, it might take thousands of years for them to even respond. To them, our entire civilization might rise and fall in what feels like just a few moments. But perhaps the most intriguing question of all is whether we could one day visit a planet around a black hole. Traveling to such a place would be incredibly difficult. The gravitational pull of a black hole is so strong that getting close to it would require enormous amounts of energy. But if we could find a way, it might be one of the most incredible discoveries in human history. Imagine standing on the surface of a planet orbiting a black hole. The sky would be unlike anything we've ever seen. Instead of a sun, you would see a massive, glowing accretion disk stretching across the sky, swirling with light and energy. Space itself would appear distorted, with light bending around the black hole in strange and eerie ways. Time would slow down, making every second feel like an eternity. It would be a place of unimaginable beauty and danger, a world on the very edge of reality. For now, the idea of planets around black holes remains a mystery. We have no direct evidence that they exist, but the more we learn about the universe, the more we realize that nature often finds a way to create the impossible. With future advancements in telescopes and space exploration, we may one day discover that these planets are not just theoretical, but real, hidden in the depths of space, waiting to be found. But how would we even detect planets around black holes in the first place? Traditional planet hunting methods rely on either detecting the wobble of a star caused by an orbiting planet's gravity, or by observing the dip in a star's brightness as a planet passes in front of it. Neither of these methods work when there's no visible star to act as a reference point. However, astronomers have come up with a few clever ways we might still be able to find these elusive worlds. One possibility is looking for their gravitational influence on the black hole's accretion disk. If a planet orbits within the disk, it could create disturbances, small gaps, warps, or irregularities in the swirling matter. These could be detectable with powerful telescopes, especially ones designed to observe high-energy radiation like X-rays. By carefully studying the structure of the accretion disk, astronomers might be able to infer the presence of planets. Another method involves looking for gravitational microlensing events. This technique relies on the fact that massive objects, like planets, can bend and magnify the light from background stars as they pass in front of them. If a planet orbits a black hole, it could occasionally move in front of a distant star, causing a temporary brightening that we can observe from Earth. This method has already been used to detect planets floating freely through space, untethered to any star, so there's a good chance it could work for planets around black holes as well. A more futuristic possibility is direct imaging using next-generation telescopes. Current telescopes struggle to take direct images of exoplanets because they are usually drowned out by the bright glare of their parent stars. But around a black hole, there is no bright star, just a faint glow of the accretion disk. If we develop telescopes capable of blocking out the disk's light while capturing the dim reflection from a planet, we might finally be able to see one of these mysterious worlds. If we do find a planet orbiting a black hole, the next big question would be, what does it look like? Would it be a barren, frozen wasteland? A storm-covered gas giant? Or something stranger than we can even imagine? Given the chaotic environment of a black hole's surroundings, it's possible that these planets would be wildly different from anything we've encountered before. Some scientists speculate that these planets could have highly eccentric orbits, meaning they might swing wildly between extreme heat and extreme cold. As they move closer to the black hole, they could be bombarded with intense radiation, causing their atmospheres to boil away. But as they move farther out, they could freeze over entirely. These extreme temperature fluctuations could create bizarre landscapes, worlds covered in layers of ice that periodically melt and refreeze, forming enormous glaciers, towering ice spires, or even underground oceans insulated from the harsh conditions outside. Other planets might be permanently locked in place by the black hole's gravity. Just as our moon always shows the same face to Earth, a planet in a tight orbit around a black hole might always have one side facing the glowing accretion disk while the other side remains in perpetual darkness. This would create an environment of extremes, with one side of the planet bathed in scorching radiation, while the other side is frozen solid. The narrow strip between these two extremes, the twilight zone, could be the only place where conditions are stable enough for an atmosphere to exist. But perhaps the strangest possibility of all is that some of these planets could be habitable. If a planet orbits a black hole at just the right distance, it could receive a steady amount of heat from the accretion disk, much like how Earth receives energy from the Sun. This energy could allow liquid water to exist on the surface, creating the potential for life to emerge. In fact, some researchers have speculated that planets orbiting black holes might be among the best places to look for alien life. The reason is simple: time dilation. As we discussed earlier, the intense gravity of a black hole slows down time for anything that gets too close. This means that from an outside observer's perspective, life on a planet near a black hole might evolve at an accelerated rate. If an alien civilization developed on one of these planets, they could advance technologically at an astonishing pace compared to us. But what would life on such a planet even look like? In the absence of a traditional day-night cycle, life forms might evolve completely different biological rhythms. They might rely on heat from the accretion disk instead of sunlight, or they could develop entirely new ways to harness energy. If the planet has a thick atmosphere, creatures might evolve to navigate through dense, swirling clouds, using infrared vision to see through the haze. If the planet is constantly bombarded by radiation, life might evolve protective bioshields, natural defenses against the high-energy particles streaming from the black hole. Some have even speculated that intelligent life on a black hole planet might be fundamentally different from anything we know. If time moves more slowly for them, they might perceive reality in a way we can't even comprehend. To them, our universe could appear to be rushing by at an incomprehensible speed, making communication with them nearly impossible. If we ever manage to make contact, we might find that their entire civilization operates on a timescale that makes our own history seem like the blink of an eye. And what if these civilizations already exist? Could advanced extraterrestrials have chosen to live near black holes on purpose? Some theories suggest that highly advanced civilizations might seek out black holes as energy sources. A Type 3 civilization on the Kardashev scale, one that can harness the energy of an entire galaxy, might be able to extract power from a black hole using a process called the Penrose mechanism. By sending matter into the black hole's ergosphere, the region just outside the event horizon, they could extract rotational energy from the black hole itself, essentially turning it into an enormous power generator. If such a civilization exists, their technology would be so advanced that we might not even recognize it. Instead of building cities on the surface of a planet, they might create vast space stations orbiting the black hole, using its immense energy to power artificial worlds. They might have structures hidden within the accretion disk itself, designed to withstand the extreme conditions. If they'd been living near black holes for millions or even billions of years, their entire existence could be beyond anything we can imagine. But if these civilizations are out there, why haven't we seen them? One possibility is that they are simply too far away for us to detect. Another possibility is that they don't want to be found. If a civilization has the technology to harness the energy of a black hole, they might also have the ability to cloak themselves, hiding their presence from prying eyes. They could be watching us right now, studying our primitive technology from the depths of space, waiting for the right moment to reveal themselves. The idea of planets forming around black holes is still a mystery. We don't yet have the technology to prove whether they exist, but the more we learn about the universe, the more we realize how little we truly know. If these planets do exist, they could be home to some of the most extreme environments in the cosmos, worlds shaped by the immense power of gravity, radiation, and time itself. And if life has found a way to survive there, it would mean that the universe is even stranger, more mysterious, and more incredible than we ever imagined. If planets around black holes exist, they would challenge everything we think we know about planetary formation, habitability, and even the very nature of life itself. The traditional view of planets forming in the protoplanetary disks of young stars has served us well in explaining the planets we see around our Sun and other stars, but black hole planets, sometimes called planets, would require us to rethink those ideas entirely. One of the biggest questions is, how could planets even form around a black hole in the first place? Black holes are typically born from the collapse of massive stars, and when a star collapses, the explosive supernova that follows tends to obliterate or eject any nearby material. This means that any planets that once orbited the original star would likely be destroyed or flung away into the depths of interstellar space. So if planets do exist around black holes, they would have to form in a completely different way. One possibility is that these planets could form within the accretion disk, a vast, swirling structure of gas, dust, and matter spiraling into the black hole. In some ways, this resembles the protoplanetary disks that surround young stars, where planets normally form. However, an accretion disk around a black hole is far more extreme. For one thing, the radiation levels in an accretion disk are immense. The material is heated to millions of degrees as it spirals inward, emitting powerful X-rays and gamma rays. This intense radiation would make it difficult for any solid material to clump together to form planets. However, some scientists suggest that there might be a safe zone within the disk, far enough from the black hole that radiation levels aren't as extreme, but close enough that there is still plenty of material to form planets. Another challenge is the stability of the disk itself. Accretion disks are not calm or orderly places. They are chaotic, turbulent environments where matter is constantly colliding and being pulled in different directions. If planets were to form here, they would have to survive the violent conditions of their birth, avoiding being dragged too close to the black hole and torn apart by tidal forces. But let's assume that, against all odds, planets do form around black holes. What would they be like? These planets would likely be very different from Earth, with extreme conditions unlike anything we've ever seen. They might be massive, ice-covered worlds orbiting in the cold outer regions of the accretion disk, or superheated, molten planets much closer to the black hole. If a planet were too close to the black hole, it could experience spaghettification, the process where an object gets stretched into long, thin strands by the intense gravitational pull. However, if it were in a stable orbit just outside this danger zone, it might exist in a strange equilibrium where time moves much more slowly relative to the rest of the universe. One of the most fascinating ideas is that these planets could potentially be habitable. The traditional definition of a habitable planet is one that exists within the Goldilocks zone of a star, where temperatures allow for liquid water to exist. But around a black hole, the source of heat wouldn't come from a star, it would come from the glowing accretion disk itself. In a 2019 study, astronomers speculated that an accretion disk could emit enough energy to provide heat to orbiting planets, essentially acting like an artificial star. If a planet orbits at just the right distance, it could receive a steady supply of warmth, allowing for conditions that might support life. However, the type of life that could survive in such an environment is a complete mystery. Radiation would be a major problem for any potential life forms. Black holes emit deadly X-rays and gamma rays that could strip away atmospheres and sterilize planetary surfaces. Any life that managed to survive would need extreme adaptations, perhaps thick atmospheric shielding, underground habitats, or biological mechanisms that resist radiation damage. But the strangest part of all might be time dilation. Because of how gravity affects time near a black hole, a planet orbiting close to the event horizon would experience time much more slowly than the rest of the universe. This means that while billions of years pass in the wider universe, only a few years might pass for the inhabitants of this planet. If intelligent life evolved on such a world, they might perceive the universe in a completely different way. To them, civilizations like ours might seem to rise and fall in an instant. If they were somehow observing Earth, they might see history play out like a time-lapse video, entire empires appearing and vanishing in what, to them, feels like mere moments. Could such civilizations exist? If they do, would they even be aware of us? Would we be able to communicate with them, or would the time distortion make it impossible? These questions push the limits of what we can even imagine. And then there's the question of artificial megastructures. If an advanced civilization wanted to harness the power of a black hole, they might not settle for living on a planet at all. Instead, they might build vast Dyson-like spheres around the black hole, capturing its immense energy for their own use. These structures could be invisible to us, hidden within the chaos of the accretion disk. Some scientists have even suggested that black holes themselves could be artificial constructs. If a sufficiently advanced civilization wanted to create an ultimate power source, they might engineer a black hole on purpose, using it as a limitless supply of energy. If that were the case, then black holes might not just be the natural remnants of dead stars. They could be the cosmic power plants of hyper-advanced civilizations. What if we're already seeing evidence of this without realizing it? Some black holes exhibit strange behavior, unusual bursts of energy, irregular flickering, or unexplained fluctuations in their accretion disks. Could these be signs of extraterrestrial engineering? And if civilizations do exist near black holes, what would they think of us? Would they see us as primitive beings living in the slow, ordinary flow of time, unaware of the deeper mysteries of the universe? Would they see our world as a fleeting moment, barely worth noticing? Or would they reach out, trying to communicate across the vast stretches of space and time? The mysteries of black hole planets challenge everything we think we know about the universe. They push the boundaries of astrophysics, planetary science, and even the search for extraterrestrial life. We don't yet know if these planets exist, but if they do, they could be some of the most extreme, fascinating, and mind-bending worlds in the cosmos. And if life has found a way to thrive in such a bizarre environment, it would mean that the universe is not only stranger than we imagine, it is stranger than we can imagine. If planets around black holes exist, they might represent an entirely new class of worlds. Planets that defy our current definitions of habitability, formation, and even the flow of time itself. The possibility of such planets raises more questions than answers, and every angle of this mystery leads to even deeper, more mind-bending ideas. One of the most intriguing aspects of black hole planets is their potential stability. In our solar system, planets orbit in predictable, nearly circular paths around the Sun due to its gravitational influence. But black holes, with their immense gravitational pull, create a much more extreme environment. Would planets in these systems have stable orbits, or would they eventually spiral inward and be consumed by the black hole? Orbital stability is a challenge in any planetary system, but the presence of a black hole makes things even more complicated. If a planet forms from the accretion disk, it would have to contend with the disk's turbulent forces, radiation, and powerful gravitational tides. However, if a planet formed at a safe distance, far enough to avoid being pulled in but close enough to stay bound, it could, in theory, maintain a stable orbit for millions or even billions of years. The biggest risk would come from gravitational interactions with other objects. If a large mass, such as a passing star or another black hole, disrupted the system, a planet's orbit could be thrown off balance. It could be ejected into deep space, flung into the accretion disk, or worse, dragged beyond the event horizon, where it would be lost forever. Interestingly, some black holes exist in binary systems, meaning they orbit alongside a regular star. In such a case, a planet could theoretically orbit the entire system rather than the black hole itself. These planets, sometimes called circumbinary planets, would experience a bizarre mix of gravitational forces, constantly shifting between the pull of the black hole and the companion star. Now, let's go even further. If planets around black holes do exist, what might they be made of? Traditional planets, like those in our solar system, are composed of rock, ice, gas, or a mixture of all three. But in a black hole system, the conditions for planet formation could be so extreme that entirely new types of planets emerge. For example, some theories suggest that a planet forming in an accretion disk could be made primarily of heavy elements. The intense radiation and energetic collisions within the disk could strip away lighter materials, leaving behind only the densest substances. This could lead to the formation of ultra-dense, metal-rich planets unlike anything we've seen before. Another possibility is that these planets could be covered in exotic forms of matter. Neutron stars, which are formed from the collapse of massive stars, are composed of an incredibly dense material called neutronium. If a planet formed under similar conditions, could it be made of something just as strange? Could it have an ultra-dense core, a surface covered in exotic particles, or even a crust made of metallic hydrogen? And then there's the question of what these planets would look like. Would they have atmospheres? Would they have clouds, oceans, or even weather systems? The radiation from the black hole might strip away atmospheres over time, leaving only barren, airless worlds. But if a planet were massive enough, it might be able to hold onto an atmosphere, despite the harsh environment. If life ever developed on one of these planets, it would have to be incredibly resilient. The radiation alone would be enough to kill most known forms of life. But some extremophiles on Earth have shown that life can survive in conditions once thought impossible. Could black hole planets host life forms that feed off radiation, live underground, or even exist in forms we can't yet imagine? One of the most fascinating aspects of this idea is the impact of time dilation. Around a black hole, time moves slower compared to the rest of the universe. If a planet were close enough to the event horizon, a single year for the inhabitants of that planet could correspond to thousands, or even millions, of years for the outside universe. Imagine an advanced civilization evolving on such a world. To them, the entire history of the human race might pass in what feels like the blink of an eye. If they were watching us from their world, they would see our history unfolding at an unimaginable speed. Empires would rise and fall in an instant. Wars, revolutions, scientific discoveries, it would all happen so quickly that they might not even perceive individual events, just a blur of motion across the ages. If they ever tried to communicate with us, it would be an almost impossible task. By the time they sent a message, we might already be long gone. And if we tried to send a message to them, they might experience it as an incredibly slow transmission, taking centuries or even millennia to fully receive. But what if they found a way around this? What if they had technology advanced enough to manipulate time, allowing them to interact with us despite the vast differences in temporal experience? Could they observe us in real time? Could they send information across time itself, warning us of dangers or offering knowledge beyond our understanding? And here's another mind-blowing thought. What if these civilizations don't just observe us, they influence us? What if moments of sudden inspiration, breakthroughs in science, or even unexplained events in human history are the result of beings living near black holes reaching out in ways we can't yet comprehend? The possibilities are endless. Could these civilizations even exist outside of time as we know it, experiencing the universe in a way that defies human understanding? Could they have found a way to escape the flow of time entirely, living in a state of existence where past, present, and future are meaningless concepts? If such beings exist, we may never be able to understand them. They would perceive reality in a completely different way, operating on a scale so vast that our entire civilization might seem like a brief flicker of light in the darkness. But even if life doesn't exist on these planets, the existence of black hole planets alone would be one of the most profound discoveries in the history of science. It would show that planets can form in environments far beyond what we once thought possible, expanding our understanding of planetary formation and challenging the very nature of habitability. And if we ever find one of these planets, it could open the door to entirely new frontiers in space exploration. Could we one day send probes to a black hole planet, gathering data from the most extreme environment in the universe? Could we find evidence of unknown physics, new types of matter, or even structures built by advanced civilizations? Every question we ask leads to more mysteries. If planets around black holes exist, how many are there? Are they common, or are they incredibly rare? Do they exist only around certain types of black holes, or can they form in any system? Could they be hiding in plain sight, waiting to be discovered? The search for black hole planets is just beginning, and the possibilities are endless. Whether they exist as barren, lifeless rocks or as the homes of civilizations beyond our understanding, they represent one of the greatest mysteries in the cosmos. And as we continue to explore the universe, we may one day find the answers to questions we never even thought to ask. The idea of planets forming around black holes forces us to rethink everything we know about planetary systems. In a traditional star system, planets form from the protoplanetary disk, a swirling cloud of gas and dust left over from the star's formation. This process, while still not fully understood, follows a relatively well-established pattern. However, around a black hole, the environment is completely different. Instead of a calm, warm nebula nurturing young planets, you have an accretion disk, a chaotic, ultra-hot, radiation-filled maelstrom of matter spiraling into the abyss. Could planets really form in such a violent region? One possibility is that, in some cases, the accretion disk could settle into a relatively stable structure with cooler outer edges. If dust and gas accumulate at a safe distance from the black hole, they might clump together over millions of years, eventually forming planets. However, there's a major problem. The heat and radiation from the inner parts of the accretion disk could make it extremely difficult for solid material to stick together long enough to grow into a planet. Another possibility is that planets don't form in the accretion disk at all but instead are captured from elsewhere. A rogue planet, one that has been ejected from its home system, could be drawn in by the black hole's gravity and end up in a stable orbit. This idea is more plausible since we know rogue planets are common in the universe. Some estimates suggest that for every star in the galaxy, there may be several rogue planets drifting through interstellar space. If even a small fraction of those were captured by black holes, then black hole planets might not be as rare as we think. But if planets do orbit black holes, what kinds of conditions would they experience? First, there's the issue of radiation. Black holes themselves don't emit light, but their accretion disks do. The swirling matter around a black hole can reach millions of degrees, producing X-rays and gamma rays in enormous quantities. Any planet orbiting too close would be bombarded with deadly radiation, making it extremely inhospitable to life as we know it. However, if a planet orbits far enough away, it might escape the worst of the radiation. In fact, some researchers have suggested that if a planet were positioned just right, the light from the accretion disk could provide enough warmth to sustain liquid water on its surface, similar to how a star provides heat for planets in a habitable zone. This idea, sometimes called the black hole habitable zone, suggests that under the right conditions, a planet around a black hole could theoretically support life. But life in such a system would be fundamentally different from anything we know. For one thing, the sky would be unlike anything seen on Earth. Instead of a bright, warm sun, the sky would be dominated by the eerie glow of the accretion disk. Depending on the black hole's activity, the brightness might change dramatically over time, with sudden flares of radiation and bursts of high-energy light. A civilization living on such a planet would have to adapt to these extreme changes, perhaps by living underground or developing shielding against radiation. Another strange consequence of living near a black hole is the effect of time dilation. As predicted by Einstein's theory of relativity, time slows down in strong gravitational fields. The closer a planet is to the black hole, the slower time would pass relative to the outside universe. This means that an entire civilization could evolve on a black hole planet, experiencing only a few years while thousands, or even millions of years pass in the rest of the universe. This raises fascinating questions. If an advanced civilization lived on such a planet, would they even be aware of the rest of the universe? From their perspective, the cosmos outside their gravitational well would be accelerating at an unimaginable speed. Stars would be born and die in the blink of an eye. Galaxies would collide and merge before their eyes. If they tried to communicate with beings outside their planet, the speed difference would make it nearly impossible. But what if they found a way to manipulate time? Could a civilization living near a black hole discover methods to slow down or speed up time at will? Could they use time dilation to their advantage, experiencing the universe in a completely different way from the rest of us? If they ever left their home planet and traveled into normal space, they might find that millions of years have passed and that the galaxy they once knew is unrecognizable. And what about the physics of such a world? Gravity around a black hole is extreme, and even a slightly miscalculated orbit could send a planet plunging toward its doom. Would planets in these systems have highly elliptical orbits, swinging close to the black hole before being flung outward again? If so, how would this affect their climate and stability? One possibility is that black hole planets could have incredibly long orbital periods. If a planet orbits far enough away, it might take centuries or even millennia to complete a single trip around the black hole. This means that the inhabitants of such a planet might experience seasons that last for entire lifetimes, with periods of relative warmth followed by long stretches of deep cold as the planet moves further from the heat of the accretion disk. But what if a planet orbits not just a black hole, but a black hole in a binary system with another star? Some black holes exist in binary pairs with regular stars, meaning that planets could orbit both objects together. In this case, the planet might experience a bizarre dual environment, sometimes warmed by the star, other times bathed in the eerie glow of the black hole's accretion disk. Theoretical physics allows us to go even further. Some black holes are thought to have powerful magnetic fields, which could interact with nearby planets in strange ways. Could electromagnetic forces influence the climate, atmosphere, or even the structure of these planets? Could a planet in such a system have an atmosphere constantly shifting due to the pull of magnetic forces, creating storms and auroras unlike anything we've ever seen? And what if there are planets inside the black hole itself? Some theories suggest that black holes might contain entire universes within them. If this is true, could planets exist in these hidden dimensions, orbiting in ways that defy the laws of physics as we understand them? Could black holes be gateways to other realities, with planets and civilizations existing beyond the event horizon, invisible to us but thriving in ways we can't comprehend? The deeper we go, the stranger the possibilities become. If planets can form around black holes, how many are out there? Could entire planetary systems exist in the shadows of these cosmic giants, hidden from view but teeming with mystery? Could we one day detect them using advanced telescopes, spotting their silhouettes against the glow of an accretion disk? And what if, someday, we visit one of these planets? Would we find lifeless, desolate landscapes, or would we discover thriving ecosystems adapted to the most extreme conditions in the universe? Would we encounter civilizations that have lived for millions of years in the slowed-down time of a black hole's gravity? Would they see us as fleeting visitors, here one moment and gone the next, barely perceivable in their vastly different flow of time? These questions push the boundaries of what we think is possible. The idea of black hole planets challenges our understanding of planetary science, habitability, and even the nature of time itself. It forces us to reconsider what a normal planet is and opens the door to possibilities beyond our wildest imagination. The search for black hole planets is only beginning, and as our technology improves, we may one day find definitive proof of their existence. If we do, it will mark one of the greatest discoveries in the history of astronomy, one that will forever change the way we see the universe. The existence of planets orbiting black holes isn't just a theoretical curiosity. It's a concept that could redefine our understanding of the universe. If black hole planets are out there, they might not just be isolated objects drifting in space. They could be part of vast, unseen planetary systems, lurking in the most extreme environments imaginable. And if that's the case, then the question isn't just whether these planets exist, but how common they might be. Could the universe be filled with hidden planetary systems orbiting black holes, invisible to us but abundant in number? To answer this, we have to consider the conditions that would allow a planet to form, survive, and thrive near a black hole. One of the biggest obstacles is the intense gravitational forces at play. Black holes are known for their immense pull, which can tear apart entire stars that venture too close. This process, called spaghettification, occurs because the gravitational force on the side of an object closer to the black hole is significantly stronger than the force on the far side. This difference stretches and ultimately rips apart anything that crosses a critical threshold, known as the Roche limit. For a planet to exist around a black hole, it would need to be far enough away to avoid this destructive fate. But this brings another challenge. At greater distances, the gravitational pull weakens, making it harder for a planet to maintain a stable orbit. If a planet drifts too far, it might be flung out of the system entirely, becoming a rogue planet lost in interstellar space. This delicate balance means that planets around black holes would have to exist within a very specific orbital range, close enough to remain bound by gravity, but far enough to escape being torn apart. So how would a planet end up in such a precise location? One possibility is that it forms there naturally, from material in a black hole's accretion disk. But given the violent and chaotic nature of these disks, this seems unlikely, at least for planets as we understand them. Instead, a more probable scenario is that these planets were once part of a regular star system that got disrupted when their star turned into a black hole. When a massive star reaches the end of its life, it can explode in a supernova, leaving behind a black hole. If that star had planets before it collapsed, those planets might survive the explosion and continue orbiting the newly formed black hole. In some cases, the explosion might send the planets flying into deep space, but in others, they could remain gravitationally bound, adjusting to the new, darker reality of their system. In fact, some scientists believe that planets orbiting neutron stars, a type of stellar remnant similar to black holes, might already exist. We have detected exoplanets around pulsars, which are rapidly rotating neutron stars that emit beams of electromagnetic radiation. These planets, known as pulsar planets, are among the strangest worlds ever discovered. They endure intense radiation and magnetic fields, yet they continue to orbit their dead stars. If planets can survive around neutron stars, then perhaps they can do the same around black holes. But let's take this idea a step further. Could a black hole actually host an entire planetary system, with multiple planets orbiting in complex configurations? Imagine a world where, instead of orbiting a bright, life-giving star, planets move around an invisible, all-consuming void. Their skies would be dominated not by a familiar sun, but by the swirling, glowing ring of an accretion disk, casting eerie light across the landscape. And if multiple planets exist in such a system, could they interact with each other in ways we don't yet understand? On Earth, planetary interactions create gravitational resonances that shape our solar system's stability. The same could happen in a black hole system, but with the added complexity of extreme gravitational warping. If a planet orbits too close to a black hole, the effects of time dilation could become extreme. To an observer on the planet, time would move more slowly relative to the rest of the universe. This means that an intelligent civilization living there might experience reality very differently from us. A single day for them could be equivalent to centuries for the rest of the galaxy. If such beings looked out at the stars, they would see time speeding up, entire civilizations rising and falling in what, to them, feels like a blink of an eye. And what about communication? If we ever detected a signal from a planet near a black hole, how would we interpret it? If time is moving slower for them, would their messages arrive in strange, drawn-out patterns? Would they perceive our responses as arriving almost instantly, or would they experience frustrating delays that make communication nearly impossible? These questions don't just stretch the limits of science fiction. They challenge the fundamental ways we think about time, space, and existence itself. If planets can exist around black holes, then the universe is far more complex and bizarre than we ever imagined. But could we ever detect one of these worlds? Astronomers have proposed several ways to search for black hole planets. One method involves looking for gravitational microlensing events, where the gravity of a massive object, like a black hole, bends and magnifies the light of a distant star. If a planet is orbiting that black hole, it could create a secondary lensing effect, revealing its presence. Another possibility is to look for irregularities in the light emitted by accretion disks. If a planet passes in front of the disk from our point of view, it might create tiny, periodic dips in brightness, similar to how we detect exoplanets transiting regular stars. There's also the idea that some black hole planets might emit their own faint infrared glow. If a planet has an atmosphere or surface that absorbs and re-emits radiation from the accretion disk, we might be able to pick up this signature using sensitive infrared telescopes. In the future, more advanced instruments, perhaps even space telescopes positioned near black holes themselves, could help us confirm the existence of these mysterious worlds. But what if, instead of simply observing them from afar, we could visit a black hole planet? Imagine a future where humanity has developed the technology to travel across vast cosmic distances. What would it be like to stand on the surface of a planet orbiting a black hole? The sky would be like nothing seen on Earth. Instead of a sun, a massive, glowing disk would dominate the horizon, its light bending in strange, distorted ways due to the black hole's gravity. Depending on the planet's location, the accretion disk might bathe the landscape in eerie red light, or it might pulse with bursts of high-energy radiation. The black hole itself would be invisible, except for the way it warps the light around it, creating a gravitational lensing effect that produces a dark sphere surrounded by a bright, glowing ring. Time itself would behave strangely. If you sent a signal to a spacecraft orbiting further away from the black hole, it might take what feels like minutes to reach them, while from their perspective, years might have passed. If you left the planet and returned later, you might find that entire centuries had gone by, even though, to you, only a short time had passed. And what if we discovered life on such a planet? Would it resemble anything we know, or would it be shaped by the extreme conditions of its environment? Could there be organisms that have adapted to intense radiation, perhaps developing bioluminescent shells to protect themselves? Could there be life forms that experience time so differently from us that they perceive our movements as impossibly fast blurs? The more we think about it, the more it becomes clear that black hole planets could be among the most fascinating, mind-bending places in the universe. Their existence challenges everything we thought we knew about planetary formation, habitability, and the very nature of time itself. And as our technology advances, we may one day uncover evidence that these worlds are not just possible, but real. The mysteries of space are endless, and black hole planets are just one of the countless enigmas waiting to be unraveled. If they do exist, then somewhere out there, hidden in the darkness, entire civilizations might be living in the gravitational embrace of a cosmic giant, experiencing time in ways we can barely comprehend. And perhaps, one day, we will find them. If black hole planets do exist, the implications extend far beyond just their formation and survival. They raise profound questions about the structure of the universe, the nature of reality, and even the possibility of alternative forms of life. Could a civilization develop on such a planet, and if so, what would their perception of the universe be like? Could intelligent beings arise in an environment where time is dramatically distorted by gravitational forces? To understand this, Let's consider the effect of extreme time dilation near a black hole. Einstein's theory of general relativity tells us that time moves slower in stronger gravitational fields. If a planet orbits close enough to a black hole, days, months, or even years on its surface could pass in what feels like mere hours to an outside observer. If intelligent life evolved on such a world, their concept of history, progress, and even communication would be drastically different from our own. Imagine a civilization on a planet where a single generation experiences the rise and fall of entire empires elsewhere in the cosmos. To them, the stars beyond their system would seem to change at an unimaginable pace. If they attempted to observe the universe, they would see celestial events happening in what, to them, appears as fast-forward motion. Supernovae might erupt and fade in what seems like mere moments. Entire galaxies could shift and evolve before their very eyes. This raises an intriguing question. If we ever detected signals from such a civilization, how would we interpret them? If their perception of time is drastically different from ours, their communication could be unintelligible, either stretched beyond recognition or compressed into bursts of information that seem instantaneous. From their perspective, our responses might appear impossibly slow, making meaningful conversation nearly impossible. But what if we went there? Could humans survive on a planet orbiting a black hole? The answer depends on several factors. First, radiation would be a major concern. The accretion disk of a black hole emits intense X-rays and gamma rays, which would be deadly to most known forms of life. If a planet were to exist within such an environment, it would need some kind of natural shielding, perhaps a thick atmosphere or a strong magnetic field capable of deflecting radiation. Temperature would be another issue. Depending on the distance from the black hole, a planet could be scorched by the heat of the accretion disk or frozen in eternal darkness. But some regions, known as the habitable zones of black holes, might provide just the right conditions for liquid water to exist. These zones are determined not by the light of a star, but by the radiation and energy output from the accretion disk. If life did evolve in such a place, it would likely be vastly different from anything we know. On Earth, biological processes are largely dictated by the cycle of day and night, but on a black hole planet, time dilation and gravitational effects could shape life in unexpected ways. Organisms might develop unique adaptations to cope with the intense gravity, possibly evolving stronger structural support to withstand the forces pulling on them. There's even the possibility that intelligent civilizations on black hole planets could harness the extreme physics of their environment for technological purposes. Some scientists have speculated that black holes could serve as energy sources, with advanced civilizations extracting power from their rotational energy or the heat of the accretion disk. If such beings exist, they might have technology beyond anything we can comprehend, perhaps even capable of manipulating space-time itself. And what about space travel? If an intelligent species lived on a black hole planet, would they ever be able to leave? The intense gravity would make escape incredibly difficult, requiring energy levels far beyond what humans currently have access to. If they developed space-faring technology, their spacecraft would have to contend with extreme gravitational forces and relativistic effects, making interstellar travel an immense challenge. But let's take this a step further. What if a civilization learned to use a black hole as a means of travel? Some theories suggest that black holes could act as gateways to other regions of the universe, perhaps even to entirely different realities. If a species on a black hole planet discovered a way to manipulate these gateways, they might be capable of interdimensional travel, moving between universes as easily as we cross oceans. The idea of black holes as portals has long fascinated scientists and science fiction writers alike. Some theories propose that black holes could connect to wormholes, tunnels in space-time that link distant parts of the universe. If such pathways exist, could a civilization near a black hole learn to navigate them? If so, they might not only explore other star systems, but entire cosmic domains beyond our comprehension. All of this leads to one final, mind-bending possibility. What if we are already being watched by beings from a black hole civilization? If time dilation works in their favor, they might have been observing Earth for what, to them, feels like mere days, while for us, millions of years have passed. Could their technology allow them to manipulate time in ways we don't yet understand? Could they be waiting for the right moment to make contact? The more we explore these ideas, the clearer it becomes that black hole planets could be among the most fascinating and mysterious worlds in the universe. They challenge our understanding of physics, time, and the very nature of reality. And as our telescopes and scientific instruments become more advanced, we may one day discover that these strange, hidden worlds are not just theoretical, but real. The mysteries of black hole planets are far from solved, but one thing is certain: if they exist, they hold the potential to change everything we know about the cosmos. Perhaps, in the vast darkness of space, entire civilizations are thriving under the gravitational embrace of a black hole, living in a reality so different from ours that we can barely begin to comprehend it. And perhaps, one day, we will find a way to reach them. If we ever do reach a civilization living around a black hole, the implications would be staggering. Imagine the knowledge they could possess, having potentially observed the universe at a different rate than we do. If time on their planet moves slower relative to the rest of the universe, they could witness cosmic events in high speed, allowing them to study things like galaxy formations, star deaths, and even the expansion of the universe in ways we never could. Their understanding of physics, relativity, and space-time might be far more advanced simply because they experience time differently. But how would we communicate with them? If our perception of time is vastly different from theirs, conversations could be stretched out over centuries or compressed into incomprehensible bursts of information. We might perceive their messages as static or garbled noise, while they might see our responses as impossibly delayed. If we ever detect a mysterious signal from deep space, could it be a message from a civilization living near a black hole, struggling to communicate across the vast gap in time perception? And what if they are already aware of us? If they have the technological capability to harness black hole physics, could they have found a way to observe us without revealing their presence? Some scientists speculate that advanced civilizations might use gravitational lensing to magnify and observe distant planets, meaning a civilization near a black hole might have the perfect vantage point to study us without us ever knowing. But what if they're not just observing? What if they're capable of manipulating space-time itself? Some theories suggest that civilizations advanced enough to harness the energy of a black hole could potentially create artificial wormholes, bending space and time to travel instantaneously across vast distances. If such a civilization exists, they might already have the ability to travel between galaxies, or even between universes. That brings up a truly mind-bending question: could black holes themselves be artificial? If a sufficiently advanced civilization exists around a black hole, could they have engineered it? Could some black holes in the universe be remnants of ancient civilizations that reached the pinnacle of technology and used black holes as machines, perhaps as energy sources, star factories, or even gateways to parallel realities? There's even the possibility that our own universe was created by an advanced civilization using a black hole. Some cosmologists have theorized that black holes might not just be destructive voids, but rather cosmic seeds that give birth to new universes. If this is true, then every black hole in our universe might contain another universe inside of it. If civilizations around black holes discovered this, could they have learned to manipulate black holes to create entirely new realities? And if so, what does that mean for us? Could our universe be the byproduct of a highly advanced civilization from another reality? Could we be the result of an experiment conducted by beings who once lived near a black hole, harnessed its power, and triggered the birth of a new cosmos? These questions push the boundaries of science and philosophy, making us rethink everything we know about existence. If planets can form around black holes, if civilizations can thrive there, and if those civilizations can manipulate the very fabric of reality, then our place in the cosmos is far more mysterious than we ever imagined. Perhaps one day, we will build the technology to explore these enigmatic worlds. Perhaps we will uncover evidence of life thriving in the strangest corners of the universe. And perhaps, just maybe, we will discover that we were never truly alone, that among the countless black holes scattered across the cosmos, there are entire civilizations waiting to be found. If black holes truly harbor planets, civilizations, and unimaginable technologies, the very structure of our understanding of the universe must be rewritten. Everything we think we know about habitable zones, planetary systems, and the nature of life itself could be fundamentally flawed. What if life doesn't need a warm, sunlit planet like Earth? What if, instead, the true cradles of intelligence are hidden in the shadows of black holes, where time stretches, gravity warps, and the laws of physics begin to blur? Imagine the possibility that some of the most advanced civilizations in the universe aren't basking in the light of stars but instead exist in the depths of cosmic darkness, where their technology is hidden from the prying eyes of the rest of the universe. This could explain the Fermi paradox, the question of why we haven't found alien civilizations despite the vastness of the cosmos. If the most intelligent beings are living in places we've never considered looking, orbiting black holes, using their immense energy to power unimaginable advancements, then it's no wonder we haven't detected them. Could these civilizations be using black holes as cosmic cloaking devices, hiding themselves from less advanced species like us? A sufficiently advanced race could manipulate the gravitational field of a black hole to bend light around their world, making it completely invisible from the outside. They could also be using black hole mechanics to encode messages in ways we wouldn't recognize. What if the strange radio bursts we sometimes detect from deep space are actually highly compressed data signals sent by civilizations living near black holes, using time dilation to send vast amounts of information in what appears to us as just a blip? And then, there's the ultimate possibility. Could black holes be portals, not just to other parts of the universe, but to entirely different realities? The laws of physics break down at a black hole's singularity, meaning anything could be possible inside. Some physicists speculate that black holes could be wormholes to other universes. If this is true, then planets orbiting black holes might have access to a cosmic gateway, a passage to entirely new dimensions. If an intelligent species evolved near a black hole, would they have discovered how to travel through these cosmic doorways? And what if they already have? What if the reason we haven't found them is because they're not bound to a single universe like we are? If they've mastered the ability to cross between realities using black holes, then their civilizations might span across multiple universes, leaving no trace in ours because they come and go at will. If this is true, then the universe we see might be just one layer of a much greater multiverse, with countless black hole civilizations drifting between dimensions. Could some UFO sightings actually be glimpses of beings crossing between realities, appearing momentarily before vanishing again? Could our entire understanding of space travel be obsolete compared to the technology of beings who have unlocked the true power of black holes? The idea that planets could form around black holes is just the beginning of the mystery. It leads us down a rabbit hole of endless questions about time, space, life, and intelligence. If black holes can harbor planets, they might also harbor secrets that could change everything we know about the cosmos. They might be the keys to faster-than-light travel, to infinite energy, to parallel universes, or even to the very origins of our own existence. We have barely scratched the surface of what black holes are capable of. As our technology advances, as our telescopes become more powerful, and as our understanding of physics deepens, we might soon find evidence that we are not alone. And when that day comes, the answer to the greatest mysteries of the universe might be hiding in the very places we once feared the most, the cold, dark voids where black holes reign supreme. A universe where planets form around black holes is a universe far stranger than we ever imagined. If these planets exist, then they challenge the very foundations of how we define habitability, civilization, and even the nature of reality itself. The idea is both terrifying and thrilling. Terrifying because it suggests that the deepest, most mysterious places in the universe could be teeming with life, hidden from our view, using forces we can barely comprehend. Thrilling because it opens the possibility that the most advanced beings in the cosmos might be living on the edges of existence, bending time and space in ways that defy all logic. But let's take a step back and ask a more fundamental question. How could planets even form around a black hole in the first place? Traditional planet formation occurs in protoplanetary disks, massive clouds of dust and gas that surround young stars, gradually coalescing into planets over millions of years. But black holes are not stars. They don't emit light in the same way. They don't have a steady outward radiation pressure pushing against the surrounding disk. So how could a planetary system possibly form in such an extreme environment? It turns out that black holes, despite their fearsome reputation, can actually host massive accretion disks, swirling rings of gas and dust that orbit the black hole at tremendous speeds. These disks can be incredibly hot and energetic near the event horizon, but farther out, at a safe distance, they might resemble the same kind of protoplanetary disks that form around stars. In 2019, astronomers discovered evidence that thousands of planets, potentially the size of Earth or larger, could form in the cold outer regions of these disks. These planets, a term coined to describe planets forming in black hole disks, might be the first step toward an entirely new class of planetary systems. But what would life be like on such a planet? Unlike Earth, which orbits the Sun and receives constant daylight, a planet orbiting a black hole wouldn't have a typical day-night cycle. Instead, the primary source of energy would come from the glowing, searing hot accretion disk surrounding the black hole. This disk could emit enough radiation to warm planets in stable orbits, providing the necessary conditions for life. But instead of a blue sky, the sky on such a world might be pitch black, with only the swirling disk of superheated matter lighting up the heavens. Time would flow differently. Gravity would be immense. Space itself would be distorted. The experience of living there would be incomprehensible to us. And what about intelligent life? If life developed on one of these planets, it would have evolved in an environment completely different from anything we know. Their perception of time might be drastically different from ours due to relativistic effects. If their planet orbits close enough to the black hole, time for them could be moving significantly slower than for the rest of the universe. What might be a single year for them could be thousands of years for us. If a civilization arose in such a place, their history could stretch back billions of our years, yet to them, it might feel like only a few millennia have passed. This raises another mind-boggling question. Could a civilization living near a black hole actually use it for technological purposes? Black holes contain an almost incomprehensible amount of energy. The famous physicist Roger Penrose proposed that if you could drop objects into the ergosphere, the region just outside the event horizon, you could extract energy from the black hole. This is known as the Penrose process, and it suggests that black holes might be the ultimate power sources. If an advanced civilization figured out how to harness this energy, they could achieve levels of power beyond anything we can conceive. And what if they've gone even further? What if, instead of merely extracting energy, they have found a way to manipulate the black hole itself? Some theorists have suggested that an ultra-advanced species could use black holes as computing devices, essentially, natural quantum computers on an unimaginable scale. A civilization that has mastered black hole physics might not need physical technology, as we understand it. Instead, they could encode vast amounts of information directly into the structure of space-time itself. Could it be that somewhere out there, hidden in the vast darkness of the cosmos, an ancient civilization has turned a black hole into the most powerful supercomputer in existence? And then comes the final, most unsettling possibility. Could black holes be artificial? If we accept that a sufficiently advanced civilization could manipulate them, then we must also entertain the possibility that some black holes were not formed naturally. Could there be black holes in the universe that were engineered, designed as machines, as energy sources, or even as gateways to other dimensions? Some cosmologists believe that our universe itself might have originated from a black hole. If this is true, then the very fabric of reality might be the byproduct of an advanced intelligence. What if we are living inside a universe that was created by beings who once lived in another cosmos, harnessed the power of black holes, and triggered the birth of a new reality? If that's the case, then the mysteries of black holes are not just scientific, they are existential. If we ever develop the technology to explore the environments around black holes, what might we find? Could we detect artificial megastructures built to extract energy? Could we discover messages encoded in the gravitational waves emitted by a spinning singularity? Could we stumble upon a civilization that has long since transcended physical form, existing purely as information woven into the structure of a black hole itself? And then there's the terrifying thought, what if they already know about us? If there are civilizations living near black holes, they would likely have a vastly superior understanding of space-time, gravity, and the fundamental forces of the universe. Could they have already detected our presence? Could they be observing us, studying us in ways we cannot comprehend? What if, to them, we are nothing more than fleeting sparks in the vast timeline of the cosmos, mere moments in their perception of eternity? Perhaps one day, we will unlock the secrets of black holes and uncover the truth. Perhaps we will discover life, technology, or even evidence of an ancient intelligence that has been waiting in the dark for untold eons. Or perhaps we will find something even stranger, something so beyond our comprehension that it forces us to rewrite everything we thought we knew about existence. One thing is certain: the mystery of black holes is far from solved. And the more we learn, the more we realize how little we truly understand. The answers we seek might be hiding in the darkest corners of the universe, waiting for us to take the next step. But whether we are ready for those answers, that's a question only time will tell. The implications of planets forming around black holes go beyond just physics and astronomy. They challenge our very concept of what a habitable world could be. When we think of habitability, we usually imagine planets bathed in the warm glow of a star, orbiting within a comfortable range that allows for liquid water and stable conditions. But a planet in orbit around a black hole would experience a reality so foreign to us that it might as well be another dimension entirely. For one, let's talk about light. A planet around a black hole wouldn't get its light from a star in the traditional sense. Instead, its main source of illumination would likely be the accretion disk, a swirling ring of superheated matter spiraling toward the event horizon at incredible speeds. This disk could be blindingly bright, emitting everything from visible light to intense X-rays and gamma rays. The sky of such a world would be like nothing we've ever seen, an eerie, chaotic glow in one direction, while the rest of the universe appears warped and twisted due to the immense gravitational lensing of the black hole. But what if the planet orbits far enough from the accretion disk that it doesn't receive direct light? Could it still be warm enough to sustain life? Interestingly, there are ways for a planet in such an environment to maintain energy. One possibility is tidal heating. Just like Jupiter's moon Io experiences intense volcanic activity due to the gravitational pull of Jupiter and its other moons, a planet orbiting close to a black hole could experience extreme tidal forces. These forces could generate internal heat, keeping the planet warm even in the absence of direct sunlight. If this heating is strong enough, it could even maintain a subsurface ocean, much like what we suspect exists beneath the icy shells of moons like Europa and Enceladus. But let's take this even further. What if, instead of relying on an accretion disk or tidal heating, a planet around a black hole could use the black hole itself as an energy source? This is where things get truly bizarre. One potential method is through Hawking radiation, a theoretical process proposed by physicist Stephen Hawking. According to this idea, black holes are not completely black. They actually emit a faint form of radiation due to quantum effects near the event horizon. While this radiation is incredibly weak for large black holes, it becomes much stronger for smaller ones. If a planet could somehow capture and harness this radiation, it might be able to extract energy directly from the black hole itself. Then there's the even more mind-bending idea of civilizations using the black hole's rotational energy. Spinning black holes possess an ergosphere, a region outside the event horizon where spacetime is dragged along with the rotation. As mentioned earlier, the Penrose process suggests that if you drop objects into the ergosphere in just the right way, you could extract energy from the black hole's spin. Could an advanced civilization, perhaps one that evolved on a planet orbiting a black hole, find a way to exploit this effect on a massive scale? Could they build entire structures within the ergosphere, drawing unlimited energy from the black hole's rotation? And what about time itself? One of the most fascinating aspects of black holes is the way they warp time due to their extreme gravity. A planet in a stable orbit close to a black hole would experience significant time dilation, meaning time would pass much slower for someone on that planet compared to someone further away. If an advanced civilization evolved in such an environment, their perception of time would be completely different from ours. They might experience centuries while only a few years pass for the rest of the universe. To them, the history of humanity might appear to be nothing more than a brief flicker, an event so fast it's almost meaningless. But what if we take this concept further? What if a civilization learned to manipulate time dilation for their own benefit? If they could control their planet's orbit with extreme precision, they could effectively travel into the future just by moving closer to or farther from the black hole. They could slow time to an almost complete stop, allowing them to preserve their existence indefinitely while the rest of the universe moves forward. Could this be the ultimate form of survival, escaping the death of the universe itself by hiding in the warp time of a black hole's gravitational field? And this brings us to another haunting thought. What if we are not alone in this concept? What if somewhere out there, civilizations have already discovered the secret of black hole time manipulation? What if they are waiting, observing the universe, watching stars and galaxies burn out while they remain frozen in time? Could it be that the true rulers of the cosmos are not those who expand outward, but those who retreat inward, hiding in the depths of space-time itself? If such civilizations exist, they would be functionally invisible to us. We rely on light and electromagnetic signals to detect distant objects, but black holes don't emit any detectable light of their own. Any advanced civilization that has mastered black hole physics might have already disappeared from our observational reach, either by choice or by necessity. They could be waiting at the edge of event horizons, existing on a timescale so slow that we would never notice them. And then there's the ultimate question: could we one day join them? Could humanity, if it survives long enough, learn to manipulate black holes for our own survival? Some futurists suggest that if we ever face an extinction-level event, whether it's a natural disaster, an artificial intelligence uprising, or the heat death of the universe itself, our last hope for survival might be to retreat to the depths of a black hole. There, time slows almost to a stop, allowing us to preserve ourselves indefinitely. But what happens when you cross the event horizon? Does anything survive? Or is it truly the end? Physicists still debate this question. According to classical general relativity, anything that crosses the event horizon is lost forever. But quantum mechanics suggests that information can't be destroyed, leading to one of the greatest paradoxes in modern physics: the black hole information paradox. Could it be that civilizations have already figured out the answer? Have they discovered a way to pass through the event horizon and emerge on the other side, in a completely different universe? If so, what would they find? Could black holes be gateways to new realities, leading to entirely different cosmic landscapes? Some physicists believe that inside every black hole, a new universe is born. If that's true, then the real mystery isn't just whether planets can form around black holes, it's whether life can escape them. Could black holes be the cosmic highways of advanced civilizations, allowing them to traverse between universes? The more we learn about black holes, the more they defy our understanding. They are not just simple voids in space. They are engines of cosmic destruction and creation, bending reality itself. If planets can form around them, then the universe is far stranger than we ever imagined. If life can survive near them, then intelligent civilizations could be hiding in places we never thought to look. And if black holes are more than just remnants of dead stars, if they are cosmic gateways, energy sources, or even artificial constructs, then our entire understanding of the universe is incomplete. One day, we may find the answers. We may build spacecraft capable of venturing close to a black hole, observing its accretion disk up close, searching for signs of planets, civilizations, or even artificial megastructures. But until then, we are left with questions that challenge everything we think we know about existence itself. If black holes are more than just remnants of collapsed stars, if they can host planets, sustain energy systems, and warp time to unimaginable degrees, then the way we perceive the universe must fundamentally change. For most of human history, we have looked at black holes as cosmic destroyers, inescapable voids that erase everything that crosses their event horizon. But what if they are something else? What if they are not just endpoints but pathways, not just gravitational wells but cosmic engines? To understand this, let's consider an even deeper question: what is the true nature of a black hole? Einstein's theory of general relativity tells us that a black hole is a singularity, an infinitely dense point where space and time cease to function normally. But quantum mechanics tells us that information cannot simply vanish. This is the heart of the black hole information paradox. When something falls into a black hole, where does the information about that object go? Is it lost forever, or does it exist in some unknown form? Some theories suggest that black holes do not destroy information but instead encode it on their event horizon. This concept, known as the holographic principle, proposes that everything inside a black hole is somehow projected onto its surface in a two-dimensional form. If this is true, then black holes are not just cosmic dead ends, they are storage devices, recording everything that has ever fallen into them. But what if this process could be reversed? What if the information stored on a black hole's event horizon could be retrieved, reconstructed, or even re-emerged somewhere else in the universe? This leads to one of the most controversial yet fascinating ideas in modern physics: black holes as potential gateways. Some physicists theorize that black holes might connect different parts of the universe through theoretical constructs called Einstein-Rosen bridges, better known as wormholes. A wormhole is a tunnel through space-time that could, in theory, link two distant points instantly. If a civilization could find a way to stabilize a wormhole, they could use black holes as interstellar highways, traveling vast distances across the cosmos in a fraction of the time it would take using conventional propulsion. Could this explain some of the mysteries we observe in space? For example, astronomers have detected objects moving at seemingly impossible speeds near black holes, as if they were being ejected with incredible force. Some have speculated that these objects may not just be escaping the gravitational pull of a black hole, but rather emerging from a wormhole on the other side, having entered through a different black hole somewhere else in the universe. If such a system exists, it could be the key to intergalactic travel. It would mean that black holes are not merely the corpses of dead stars but the foundational structures of a vast cosmic transportation network. But this raises even more questions. Who or what could have built such a network? Did the universe itself create these pathways naturally, or were they engineered by an ancient civilization that predates anything we know? And if civilizations have already discovered the secrets of black hole travel, would they even be detectable to us? A civilization capable of manipulating black holes would have reached an energy level so far beyond our own. They could construct Dyson spheres around black holes to harvest their energy, create artificial singularities to power their technology, or even exist entirely within the warp time of a black hole's gravitational field, experiencing millennia while the rest of the universe ages around them. If such beings exist, where are they? This brings us to another paradox, the Fermi paradox. If the universe is so vast and old, why have we not detected any signs of intelligent extraterrestrial life? Some scientists propose that advanced civilizations might not expand outward into space as we expect. Instead, they might retreat inward, using black holes to slow time, preserve energy, or even transcend physical existence altogether. There is also the possibility that black holes are not just natural formations but are intentionally created. Some theories suggest that extremely advanced civilizations could engineer black holes as energy sources, data storage systems, or even as tools for experimentation with space-time itself. If we discovered a black hole with properties that don't match natural formation models, would that be proof of extraterrestrial intelligence? And what if we, as humanity, one day learn to control black holes? Right now, the idea seems impossible. We struggle just to send probes beyond our own solar system. But if we continue advancing, if we master the fundamental forces of the universe, we could one day harness the immense energy of black holes to power entire civilizations. Imagine a future where humanity is no longer bound to planets but instead constructs artificial worlds orbiting black holes, using them as energy sources, gravitational shields, and even time manipulation devices. We could place entire space stations in regions of extreme time dilation, slowing our experience of time to extend our lifespans, allowing us to outlive the natural death of stars. Or perhaps we would take it even further. If black holes truly connect to other regions of the universe, or even other universes, then our ultimate destiny might not lie in expanding through the stars, but in diving into the depths of these cosmic voids, seeking what lies beyond. Could the key to understanding the multiverse be hidden within the event horizons of black holes? Could entire universes exist within them, just as our universe might have once been born from a singularity? The deeper we look into the mysteries of black holes, the more we realize how little we understand. They are paradoxes, enigmas, and possibly the gateways to something beyond our comprehension. One day, we may unlock their secrets. We may build ships capable of surviving the plunge into their depths. We may find civilizations that have already done so. Or perhaps, we will discover that the greatest mystery of all is not what black holes take away, but what they might give back. The idea that black holes might be more than just destructive forces, that they could sustain planetary systems or even act as cosmic hubs, forces us to rethink everything we thought we knew about the structure of the universe. If planets could form around black holes, what kind of conditions would they experience? Would life, as we understand it, be possible in such extreme environments? Or would these worlds give rise to entirely new forms of existence, shaped by the intense gravity, radiation, and warp time of their dark suns? To understand the possibility of planets orbiting black holes, we have to go beyond our conventional models of planetary formation. In a typical solar system, planets form from the protoplanetary disk, a swirling mass of dust and gas left over from the birth of a star. Over time, these particles collide and stick together, growing into larger bodies through a process called accretion. Eventually, they form planetesimals, which then combine to become fully fledged planets. But black holes do not emit light like regular stars. Instead, they are surrounded by accretion disks, hot, rapidly spinning rings of gas and dust drawn in by their intense gravity. These disks can reach temperatures of millions of degrees, glowing brightly in X-ray and ultraviolet wavelengths. Could planetary formation occur within such an extreme environment? Some scientists believe it is possible. In 2019, researchers proposed a theoretical model suggesting that planets could form in the outer regions of an accretion disk, where temperatures are lower and conditions are more stable. If this is true, then black holes could host entire planetary systems, vast rings of planets orbiting the event horizon, bathed in the eerie glow of superheated gas. But what would it be like to exist on such a planet? The gravitational pull of a black hole is immense, meaning that planets would need to orbit at incredibly high speeds to avoid being pulled in. Time dilation would also be a major factor. According to Einstein's theory of relativity, the stronger the gravitational field, the slower time moves. A planet orbiting close to a black hole could experience time at a vastly different rate than the rest of the universe. This means that while only a few years might pass for someone on the planet, thousands, or even millions, of years could pass in the outside universe. This concept was famously explored in the movie Interstellar, where astronauts visit a planet near a supermassive black hole and find that every hour they spend on the surface equals 7 years in normal time. While this was a fictional scenario, the science behind it is sound. A planet close to a black hole would experience extreme time dilation, making it an ideal place for those seeking to extend their lifespans, or a prison for those unaware of the passage of time beyond their world. Another major factor is radiation. Black holes emit powerful jets of radiation as matter falls into them, which could make it difficult for life to survive. However, some theorists suggest that planets could form in a safe zone, farther from the black hole, where radiation levels are lower but the gravitational pull is still strong enough to maintain an orbit. If such planets exist, could they be home to life? This is one of the greatest unanswered questions in astrophysics. Life as we know it depends on stable conditions, moderate temperatures, liquid water, and a steady source of energy. A planet orbiting a black hole would not receive light from a sun, but it could still get energy from other sources. Geothermal activity, for example, could provide heat from within the planet itself. Tidal forces from the black hole's gravity could generate friction, keeping the planet warm. And in some cases, radiation from the accretion disk could provide enough energy to sustain exotic forms of photosynthesis. If life did evolve on such a world, it would likely be very different from anything we know. Creatures would have to adapt to extreme gravity, intense radiation, and possibly a highly unstable climate. Would they even perceive time the way we do? If they evolved on a planet where time moves slower than the rest of the universe, would they experience history at an entirely different pace? The implications of this are staggering. If planets can form around black holes, then the number of potentially habitable worlds in the universe could be far greater than we ever imagined. And if civilizations exist on these worlds, they might live under conditions so alien to us that we could barely comprehend their existence. They could be watching the universe unfold at a different rate, observing cosmic events that happen over millions of years as if they were mere moments. And then there is the question of technology. If an advanced civilization discovered how to harness the energy of a black hole, they would have access to one of the most powerful forces in the universe. Some scientists believe that highly advanced extraterrestrials might already be using black holes as power sources, using techniques such as the Penrose process, a theoretical method of extracting energy from a rotating black hole. If this is the case, could we detect them? Some researchers have proposed looking for unusual emissions or gravitational anomalies that could indicate artificial activity around black holes. If we ever find a black hole behaving in ways that do not match natural expectations, it might be the first evidence of an advanced civilization beyond our own. And what about us? Could humanity one day settle near a black hole? It might seem like science fiction, but some futurists believe it is possible. If we can build space stations capable of withstanding the radiation and gravity, we could establish permanent colonies orbiting black holes, using them as energy sources and scientific outposts. Such colonies would be unlike anything we have ever built. They would exist in the most extreme environments imaginable, where time itself moves differently, and where the fabric of space bends in ways we can barely understand. But they could also be the key to unlocking some of the universe's greatest mysteries. By studying black holes up close, we could learn more about the nature of space, time, and the very fabric of reality. Perhaps, in the distant future, black holes will not be seen as terrifying voids of destruction but as the keystones of cosmic civilization. Perhaps they will be the places where the most advanced beings in the universe gather, where the deepest secrets of existence are studied and understood. And maybe, just maybe, they will be the gateways to something even greater, new dimensions, new universes, or even the key to transcending the physical limits of reality itself. Black holes, once thought to be the ultimate cosmic dead ends, might instead be the foundation for entirely new kinds of planetary systems. But if planets can truly form around these cosmic monsters, how would they be structured? Would they resemble the planets in our solar system, or would they be something completely alien, shaped by the extreme physics of their environment? To fully understand what a planet around a black hole might look like, we need to break down the unique forces at play. First, gravity. The gravitational pull of a black hole is immense, warping space-time itself. Any planet that manages to maintain an orbit around a black hole must balance the intense pull of gravity with the centrifugal force generated by its motion. This means that, depending on the black hole's mass, planets might need to move at incredible speeds to avoid spiraling inward. The closer they orbit, the more extreme these effects become. For example, near the event horizon, the point beyond which nothing can escape, a planet would have to move at nearly the speed of light to remain in a stable orbit. If such a planet existed, the relativistic effects would be mind-boggling. Time dilation would be so severe that while only a few days or weeks might pass for an observer on the planet, entire centuries or even millennia could pass in the outside universe. If an astronaut were to visit such a world and return, they might find that everyone they ever knew had long since passed away. This leads to another important question: what kind of material could survive such conditions? Ordinary matter as we know it might not be strong enough to withstand the immense gravitational stresses. Instead, planets in these extreme environments might be made of exotic materials, superdense elements forged under the pressures of the accretion disk. Some researchers speculate that planets around black holes could be composed largely of degenerate matter, similar to the interiors of neutron stars. These would be hyperdense, solid spheres, resistant to the tidal forces that would otherwise tear ordinary planets apart. Then there's the issue of energy. Most planets in our solar system depend on a star for heat and light, but a black hole does not emit traditional starlight. However, this does not mean a planet would be shrouded in darkness. The accretion disk of a black hole, made up of swirling gas and dust, can glow with incredible brightness due to friction and extreme temperatures. A planet orbiting in the outer regions of this disk might receive a steady amount of radiation, enough to sustain an atmosphere and even liquid water. In fact, some scientists believe that such a planet could resemble a tidally locked world, one where one side permanently faces the black hole while the other remains in perpetual night. The day side would be bombarded with energy from the accretion disk, possibly glowing with a deep red hue, while the night side could be frozen and dark. Such a world would have a stark contrast in climate, with an intense heat gradient driving powerful storms and winds that rage across the surface. Now, if we take this idea further, what if there were not just one, but multiple planets orbiting a black hole? Could an entire planetary system exist around one of these cosmic giants? Theoretically, yes. If planets can form in the outer regions of an accretion disk, then it stands to reason that multiple planets could coalesce over time, just as they do in traditional star systems. These planets might exist in a delicate balance, their orbits carefully tuned to avoid gravitational disturbances that could send them spiraling into oblivion. And if planets can exist around black holes, what about moons? Could a planet orbiting a black hole have its own system of satellites? This is where things get even more fascinating. Moons would experience tidal forces unlike anything in our solar system, as they would be stretched and compressed by the combined gravitational pull of their parent planet and the black hole itself. This could generate immense internal heat, potentially making even an otherwise frozen world geologically active. For example, Jupiter's moon Io experiences extreme tidal heating due to the gravitational pull of Jupiter and its neighboring moons, resulting in constant volcanic activity. Now imagine a moon orbiting a planet near a black hole, where gravitational forces are millions of times stronger. Such a moon might have a surface constantly reshaped by massive eruptions, with lava flows that never cool and geysers of superheated gas shooting miles into space. But could life exist in such an environment? If life has taught us anything, it's that it can thrive in the most unexpected places. On Earth, we have found extremophiles, organisms that live in deep-sea hydrothermal vents, under crushing pressures and extreme temperatures. Some scientists believe that life could survive on a planet orbiting a black hole by relying on chemosynthesis, a process that does not require sunlight. Instead, organisms could extract energy from chemical reactions occurring in the planet's interior, similar to the life forms that thrive in deep ocean trenches. And if life exists on these planets, how would it evolve? A planet experiencing extreme time dilation would see the outside universe evolve at a vastly different pace. Civilizations living on such a world might find that while they develop slowly, the rest of the cosmos advances at an accelerated rate. They might be completely unaware of changes occurring in the universe, only to look up at the sky one day and realize that entire galaxies have shifted positions in what feels like an instant. This raises another mind-bending possibility. What if an advanced civilization chose to live near a black hole intentionally? The ability to manipulate time could be a huge advantage. A civilization that mastered the technology to establish a stable orbit around the black hole could effectively slow their own subjective time while watching the universe unfold and fast forward. They could gather knowledge at an accelerated rate, studying cosmic events in real time while only experiencing a fraction of that time themselves. In the far future, humanity might even consider using black holes as a means of time travel. By placing a spacecraft in a carefully calculated orbit around a supermassive black hole, we could theoretically use time dilation to travel into the future. A mission that spends only a few years near the event horizon could return to find that centuries have passed for the rest of humanity. This could allow us to witness long-term cosmic events, such as the evolution of stars and galaxies, in a single human lifetime. But there's another, even more bizarre possibility. What if black holes themselves are artificial? Some physicists have speculated that incredibly advanced civilizations, far beyond our technological capabilities, might be capable of creating or manipulating black holes for energy generation. If true, then some of the black holes we observe in the universe might not be natural at all but the remnants of ancient megastructures. And what about the famous concept of a black hole as a wormhole? Some theoretical models suggest that black holes might be connected to other points in space-time, acting as shortcuts to distant galaxies or even alternate universes. If this is the case, then planets orbiting a black hole might be positioned at the very edge of cosmic highways, existing on the borders of unknown realms. The more we explore the possibilities, the more we realize how little we truly know. Could planets form around black holes? The evidence suggests that, under the right conditions, they could. Could life exist in such extreme environments? It is not beyond the realm of possibility. And could advanced civilizations be using black holes for purposes beyond our understanding? That is perhaps the most tantalizing mystery of all. The universe is full of secrets waiting to be uncovered, and black holes might hold some of the most profound answers about existence itself. As we continue to push the boundaries of science and explore the deepest corners of space, we may one day find that these cosmic giants are not just voids of destruction but cradles of creation, worlds unlike anything we have ever imagined. If black holes can support planetary systems, and potentially even life, what does that tell us about the deeper nature of the universe? Could the existence of planets around black holes be a clue to something even more fundamental? Something about the very structure of reality itself? One of the most intriguing implications of black hole planetary systems is how they challenge our understanding of habitability. Traditionally, we think of the habitable zone, the region around a star where liquid water can exist, as the key factor in determining whether life can emerge. But black holes suggest an entirely new kind of habitability, one that doesn't depend on a traditional star at all. Instead, energy sources like accretion disks, relativistic jets, or even radiation from matter falling into the event horizon could provide the conditions necessary for life to survive. This raises an even bigger question. If life can exist around black holes, how common might it be? Could black hole planets be far more numerous than we think, hidden away in the depths of space? Consider the fact that supermassive black holes exist at the center of almost every large galaxy, and stellar mass black holes are scattered throughout the cosmos. If planetary formation around black holes is possible, then entire civilizations could be thriving in places we have never even considered looking. And what about the physics of these worlds? One of the strangest effects of orbiting near a black hole is the way light behaves. Because black holes warp space-time so drastically, light does not travel in a straight line. Instead, photons can become trapped in curved trajectories, creating bizarre visual distortions. On a planet orbiting close to a black hole, the sky might look completely alien, stars might appear stretched and distorted, or even duplicated due to gravitational lensing. There's also the eerie phenomenon of light echoes. If a planet is positioned near a black hole's accretion disk, light from the disk could take multiple paths to reach the planet's surface, creating strange effects where an observer might see delayed or duplicated images of the same event. Imagine standing on a world where a sunrise happens twice, once in real time, and again moments later as the light loops around the black hole. And then there's the possibility of entire civilizations adapting to these unique conditions. If intelligent life evolved on a planet orbiting a black hole, their perception of time, space, and even fundamental physics might be radically different from our own. They might see the universe as a constantly shifting, warped reality, where time does not flow in a simple linear fashion. Even their concept of history could be unlike anything we understand. If their world experiences extreme time dilation, they might witness the evolution of entire galaxies while only experiencing a fraction of that time themselves. This could lead to a vastly different way of thinking, perhaps a civilization that sees history as something unfolding in real time, rather than something that must be pieced together from ancient records. But what if black holes are more than just cosmic anomalies? Some physicists speculate that black holes could be gateways to entirely new realms of physics, perhaps even to other universes. If this is the case, then planets orbiting black holes might not just be isolated worlds, but outposts on the very edge of reality. Consider the idea that black holes could be wormholes, connecting distant points in space or even different dimensions. If a civilization could master the technology to manipulate these structures, they could potentially use black holes as transportation hubs, jumping from one part of the cosmos to another in an instant. In such a scenario, planets orbiting black holes could serve as natural way stations, positioned along intergalactic travel routes. And if black holes can connect to other universes, what would that mean for the planets orbiting them? Could some of these worlds be receiving energy, matter, or even life from another cosmos entirely? This idea, while speculative, forces us to rethink what we consider the limits of reality. There's also the question of whether black holes themselves might be artificial. If an advanced civilization had the ability to manipulate matter and energy on a cosmic scale, they might be able to create, or even control black holes for their own purposes. Some have suggested that extremely advanced beings, perhaps even beyond what we consider biological life, might use black holes as computing devices. This concept, known as the black hole computer hypothesis, suggests that black holes could be used to process vast amounts of information, encoding data in the event horizon itself. If true, then black holes might not just be celestial objects, but highly advanced machines, built for purposes beyond our comprehension. If black holes can be used as computational devices, could they also be used as communication hubs? Some physicists have theorized that signals might be transmitted using gravitational waves, ripples in space-time caused by massive objects moving and colliding. If a civilization had the ability to encode information in these waves, they could send messages across the universe using black holes as relay stations. And if this is happening, then we might already be surrounded by signals, messages encoded in the gravitational ripples passing through our galaxy, waiting to be deciphered. If we ever learn how to read these signals, we might discover that we are not alone, that civilizations have been communicating across cosmic distances for eons, using black holes as the ultimate communication network. But perhaps the strangest possibility of all is the idea that black holes themselves could be conscious. If black holes are capable of processing information, and if they exist in a state where time and space behave in ways we don't fully understand, could they possess some form of awareness? This idea, while highly speculative, is not entirely outside the realm of theoretical physics. Some researchers have suggested that consciousness might be tied to the structure of space-time itself. If this is true, then the extreme warping of space-time around a black hole could create conditions where some form of intelligence, or at least information processing, emerges naturally. In such a scenario, a black hole might not just be a mindless void, but something more, something capable of thought, observation, or even communication. If black holes are, in some sense, aware, what would that mean for the planets orbiting them? Would these worlds be part of an unimaginably vast intelligence, existing within the gravitational embrace of a cosmic mind? Could the beings living on these planets perceive or interact with the black hole in some way? This brings us to one final, unsettling question: what if our own universe is the result of a black hole? Some cosmologists propose that the Big Bang itself could have been the formation of a black hole in a higher dimensional space. If true, then our entire reality might exist within the event horizon of a massive black hole in another universe. And if that is the case, then every galaxy, every star, and every planet, including those orbiting black holes, might be part of an endless cycle, where black holes give birth to new universes in a never-ending chain of creation. The more we study black holes, the more they challenge our deepest assumptions about the nature of reality. They are not just objects of destruction, but cosmic puzzles that hint at the fundamental structure of the universe. Whether as the homes of planets, the engines of advanced civilizations, or the gateways to other realms, black holes may hold the key to answering some of the greatest mysteries of existence. And as we continue to push the boundaries of science, one thing becomes clear: black holes are not the end. They may, in fact, be the beginning. If black holes are not the end but a beginning, then what exactly are they the beginning of? Could they represent the first step in understanding a deeper, hidden layer of reality, one that lies beyond our current understanding of physics? One of the most intriguing possibilities is that black holes serve as gateways to new universes. This idea, rooted in theories of quantum gravity and cosmology, suggests that when matter falls into a black hole, It doesn't just disappear but instead creates a new, expanding universe on the other side. This means that every black hole could be a kind of cosmic womb, birthing new realities beyond our perception. If this is true, then what does it mean for the planets orbiting black holes? Could these worlds be precariously balanced on the edge of existence, caught between one universe and another? Could they be influenced by forces from the hidden reality within the black hole itself? Some physicists suggest that the singularity inside a black hole, the point of infinite density where all known laws of physics break down, might not be a true singularity at all. Instead, it could be a bridge, a portal, or even a structure that encodes vast amounts of information about the universe that gave birth to it. If that's the case, then planets orbiting black holes might not just be isolated worlds, but places where the very nature of reality is fundamentally different. Imagine a planet where space-time behaves unpredictably, where gravity fluctuates in ways that defy logic, where time runs at different speeds in different regions, and where the very fabric of reality shifts based on proximity to the black hole's event horizon. Such a world could be unlike anything we've ever conceived, a place where the laws of physics are rewritten by the cosmic forces surrounding it. And what if life evolved on such a planet? How would beings that emerged in this extreme environment perceive the universe? Their understanding of time might be vastly different from ours. For them, the past, present, and future might blur together in ways that we can't even comprehend. Their biology could be adapted to survive in gravitational fields that constantly shift. Their civilizations might develop technologies that manipulate space-time itself, bending reality in ways that seem like magic to us. But even more unsettling is the idea that black holes might not just be natural objects, they might be constructed. Some theorists have proposed that sufficiently advanced civilizations, capable of manipulating energy and matter on an astronomical scale, could create black holes for various purposes. One possibility is that black holes could be used as power sources. The immense gravitational energy of a black hole could, in theory, be harnessed to generate staggering amounts of energy. A civilization orbiting a black hole might have the ability to extract energy from its accretion disk, or even from the Hawking radiation slowly leaking from its surface. Another possibility is that black holes could be used as storage devices. Since black holes have an enormous capacity to encode information, an advanced civilization might use them to store vast amounts of data. In fact, some physicists believe that the entire surface of a black hole, its event horizon, functions like a holographic screen, encoding every bit of information that has ever fallen into it. If that's true, then black holes might be the ultimate cosmic archives, holding the secrets of past civilizations, lost knowledge, or even entire simulated realities. And if planets orbiting black holes exist within this framework, they might be places where this stored information leaks out in strange and unpredictable ways. But what if the civilizations that once used black holes as storage devices are now gone? What if we are looking at the remnants of a long-dead cosmic culture, one that mastered black holes, left their knowledge encoded within them, and then vanished without a trace? Could the signals we've been searching for, the messages from alien civilizations, be buried within the event horizons of black holes, waiting for us to decipher them? And if we ever figure out how to unlock the information hidden within black holes, what might we find? Could we discover the blueprints for technologies beyond our wildest dreams? Could we learn the true history of the universe, recorded and stored within these celestial archives? Or could we stumble upon something even more disturbing, evidence that we, too, are part of a simulation, a recorded construct encoded within a black hole created by beings far beyond our comprehension? This brings us to a truly mind-bending possibility. What if our own universe is itself a black hole? Some cosmologists believe that the Big Bang, the event that created our universe, might actually be the other side of a black hole in a higher dimensional space. This means that everything we experience, every galaxy, every star, every planet, might exist inside the event horizon of an unimaginably vast black hole. If this is true, then black holes within our universe might not just be gateways to other dimensions, they might be smaller versions of the process that created our own cosmos. And if our universe is a black hole, does that mean it will eventually collapse in on itself, creating yet another universe in an infinite cycle of cosmic birth and destruction? The implications are staggering. It would mean that the true nature of reality is far beyond what we currently understand. It would mean that black holes are not just voids of destruction but engines of creation. And it would mean that the planets orbiting black holes are not just isolated worlds but pieces of a much larger cosmic puzzle, one that we are only beginning to unravel. And if we ever do unlock the full mystery of black holes, we might discover something even more profound, that the universe is not a cold, indifferent void but a living, evolving system. A system where black holes are not just cosmic anomalies but the very heart of creation itself. The question, then, is not whether black holes hold the key to understanding the universe. The real question is, what happens when we finally turn that key? If black holes are the engines of creation, then what does that mean for the future of space exploration? Could we one day harness their power? Could we travel to the edge of a black hole and return with knowledge that reshapes everything we know? Could the first truly intergalactic civilizations emerge not among the stars, but in the dark regions where gravity bends space-time itself? The idea of civilizations orbiting black holes isn't just theoretical, it's a real possibility. A planet in close orbit around a supermassive black hole could, under the right conditions, receive enough energy from the accretion disk to support life. The immense gravitational forces could also allow for complex and stable orbital mechanics, meaning such a world might have existed for billions of years. But what would life on such a world actually look like? For starters, time dilation near a black hole is extreme. A civilization developing on a planet orbiting a black hole would experience time differently from the rest of the universe. If they were close enough to the event horizon, millions of years could pass outside their system while only a few centuries pass for them. This would mean that while they might feel as if they were advancing at a normal pace, the rest of the universe would evolve around them at a vastly different rate. Would they perceive the stars shifting in the sky at speeds incomprehensible to us? Would they be aware that the universe outside their world was aging at a pace beyond their comprehension? This also raises another question: what would their perception of time be? If time moves slower for them compared to the rest of the universe, would their thought processes also slow down? Or would they have adapted to this difference, experiencing time in ways we can't even imagine? Perhaps their entire biology would be tuned to function in extreme gravitational environments, with structures and forms optimized for life under conditions we would find impossible. If civilizations could evolve near black holes, could they also find a way to manipulate them? Some physicists believe that advanced civilizations might one day use black holes as energy sources. The Penrose process, for example, suggests that it's possible to extract energy from a rotating black hole. By sending a particle into a black hole's ergosphere, the region just outside the event horizon where space-time itself is being dragged around, a civilization could, in theory, harness rotational energy from the black hole. This process could provide an almost unlimited power supply, something that an advanced interstellar society would find invaluable. Could this mean that black holes aren't just naturally occurring celestial bodies, but massive cosmic machines? If a civilization could manipulate them, they might use them as stargates, shortcuts through the vast distances of the universe. Theoretical models suggest that certain types of black holes might function as wormholes, allowing for faster-than-light travel between different parts of the cosmos. If an intelligent species had the technology to stabilize these pathways, they could traverse the universe in ways that seem impossible to us. But if such civilizations exist, then where are they? Have they moved beyond our comprehension, leaving behind only the black holes as evidence of their existence? Could some black holes be artificially created, massive structures built as transportation networks or energy sources by a civilization so advanced that we mistake their technology for natural phenomena? And if a civilization has the capability to manipulate black holes, could they also create them? Some scientists have speculated that small artificial black holes might be used in the future for various applications, from energy generation to space-time manipulation. But what if a civilization took this concept further? What if they deliberately created a black hole as a method of escaping the death of their own universe? There's a theory that suggests that if the universe were ever to collapse or become uninhabitable, an advanced civilization could encode its entire existence into a black hole and send it into another universe. This would allow them to effectively preserve their knowledge, their consciousness, and their culture indefinitely. If this is possible, then black holes might be more than just remnants of dead stars. They could be the final refuge of ancient civilizations, carrying within them the last traces of worlds long forgotten. And if we could one day decode the information within black holes, what might we find? Could we uncover the remnants of lost alien languages, the histories of civilizations that once thrived before vanishing into the void? Could we unlock secrets about the true nature of the universe itself? Some theorists believe that black holes might actually encode information about the entire cosmos. The holographic principle suggests that all the information within a three-dimensional region of space could be stored on a two-dimensional surface, the event horizon of a black hole. If this is true, then every black hole might contain the complete record of everything that has ever fallen into it. This leads to an even stranger possibility. What if black holes are the universe's way of storing information? What if they are cosmic libraries, preserving everything that has ever existed? Could it be that the universe itself is an enormous information processing system, where black holes serve as memory banks, ensuring that nothing is ever truly lost? If this is true, then the planets orbiting black holes might be more than just isolated worlds. They could be positioned at the very heart of the universe's data storage system. These planets could be places where information from past epochs leaks out, where strange and unexplainable phenomena occur because the very fabric of reality is intertwined with the knowledge contained within the black hole. And what if, one day, we learn how to access this information? What if the key to understanding the deepest mysteries of the universe is hidden within black holes, waiting for us to unlock it? The real question is, will we ever be ready for what we find? If black holes are cosmic vaults of information, then what does that mean for the nature of reality itself? Could everything we see, everything we experience, be a mere projection of information stored within black holes? Some physicists suggest that the entire universe might function like a giant hologram, with black holes serving as the ultimate hard drives, encoding the past, present, and perhaps even the future of everything that has ever existed. But if black holes store vast amounts of data, then how could we ever retrieve it? The idea of an event horizon acting as a one-way information barrier has long puzzled scientists. Traditionally, we believe that anything crossing the event horizon is lost forever, but recent developments in physics challenge this idea. The black hole information paradox, one of the biggest unsolved mysteries in science, suggests that information falling into a black hole might not be destroyed but rather encoded on the event horizon itself. This means that, in some way, black holes might act as cosmic recording devices, capturing every event, every particle, and every wave of energy that has ever interacted with them. If we could decipher this encoded information, we might uncover the histories of civilizations lost to time. Imagine if, billions of years ago, an advanced alien race had the technology to store their entire knowledge base inside a black hole, ensuring their legacy would never be lost. If that were the case, then black holes wouldn't just be remnants of dying stars. They would be archives of forgotten galaxies, libraries of lost worlds, and perhaps even the final resting places of minds greater than our own. Some theorists even propose that black holes could be a means of communication across cosmic distances. What if a civilization capable of harnessing black hole physics found a way to imprint signals onto the event horizon itself, using gravitational waves to encode messages that could last for billions of years? If that were the case, then black holes wouldn't just be passive storage devices. They would be broadcasting stations, continuously sending messages into the fabric of space-time. This raises the question, if an advanced civilization wanted to communicate with future intelligent beings, what better way than by etching their knowledge onto an object that can survive for longer than stars themselves? A supermassive black hole at the center of a galaxy could act as a beacon, containing the accumulated wisdom of countless civilizations that came before us. If we ever figure out how to decode these signals, we might discover messages from entities that existed before Earth was even formed. But what if we take this idea even further? What if black holes don't just store information but actually create it? Some physicists speculate that new universes might be born from the singularities within black holes. If this is true, then every black hole in our universe could be a gateway to an entirely new cosmos, where the physical laws might be completely different from our own. This could mean that our own universe was birthed from a black hole in another reality. If so, then the singularities at the centers of black holes might not be points of destruction, but points of creation, gateways through which new realms are born. Some researchers believe that the physics inside a black hole could allow for new space-time bubbles to emerge, expanding outward into a separate universe, completely detached from our own. If civilizations existed within these alternate universes, they would have no way of perceiving us, just as we have no direct way of seeing into a black hole's singularity. And if new universes are continuously forming from black holes, then the multiverse might not just be a theoretical concept, it could be a fundamental process of cosmic evolution. And here's where things get even stranger. If black holes create new universes, then could an advanced civilization ever design a black hole in such a way that it creates a universe with conditions perfectly suited for life? Could a Type 3 civilization, one that has mastered the energy of an entire galaxy, learn to engineer black holes to seed new realities, shaping the very laws of physics within them? And if that's true, then the black hole at the center of our own Milky Way might not be just a natural feature of the cosmos. It might be something far more deliberate, placed there for reasons we can't yet comprehend. Could it be that we are living in a universe designed by beings from another reality, an artificial cosmos engineered to support life? Some scientists argue that if we ever gain the ability to manipulate black holes, we might also gain the ability to create entire new universes. If that's the case, then the ultimate fate of intelligent life might not be to explore the stars, but to transcend them, moving beyond the boundaries of our own reality and crafting new ones at will. And this brings us to the most mind-bending question of all. If civilizations can create new universes, then could we already be inside one? Could the black holes in our own universe be the fingerprints of some ancient intelligence, evidence that we are living inside a cosmic structure built by beings who existed long before us? If so, then looking into a black hole is not just looking into the void. It's looking into the very mechanism that may have birthed us. It's staring into the cosmic machine that may have been designed for a purpose beyond our understanding. And if we ever figure out how to harness that power, how to control the creation of space and time itself, then we may not just be observers of the universe. We may become its architects. If black holes are cosmic architects, then what does that mean for the future of our civilization? If we ever gain the ability to manipulate them, we wouldn't just be explorers of the universe, we would become its engineers. Right now, our understanding of black holes is limited to observation, but what if, one day, we could interact with them directly? There's a mind-blowing theory that suggests black holes could be used as engines for advanced civilizations. This is called the Penrose process, an idea proposed by physicist Roger Penrose. It suggests that if a spacecraft were to orbit near the ergosphere of a rotating black hole, a region just outside the event horizon where space-time itself is dragged around due to the immense gravity, then it could steal some of the black hole's rotational energy. Theoretically, by launching and splitting objects at the right moment, a civilization could extract energy from a black hole and use it to power their technology. This concept isn't just theoretical. Some astrophysicists believe that highly advanced alien civilizations, known as Type 3 on the Kardashev scale, could already be doing this, harvesting the rotational energy of supermassive black holes to power their intergalactic empires. If true, then black holes might not just be cosmic mysteries to be studied from a distance. They might be the most valuable energy sources in the entire universe, capable of sustaining civilizations beyond anything we can currently imagine. But what if we go even further? If black holes can store vast amounts of information, if they can function as cosmic hard drives, if they can potentially create new universes, and if they can serve as power sources for advanced civilizations, then could they also be portals? Could they be gateways that allow for travel between different regions of the universe? This is where the idea of Einstein-Rosen bridges, better known as wormholes, comes into play. A wormhole is a theoretical tunnel through space-time, connecting two distant points. Some scientists believe that certain black holes might actually be wormholes, allowing for travel across vast distances in an instant. Here's where things get weird. According to some interpretations of quantum mechanics, the entanglement of particles could be linked to wormholes. If true, then black holes might not be isolated entities at all. They might be connected to other black holes through hidden pathways that stretch across the universe. If we ever figure out how to stabilize and navigate these connections, we might unlock the ultimate form of space travel, one that doesn't rely on rocket engines, but instead bends the very fabric of reality itself. But what if someone has already done this? What if, out there in the depths of space, a civilization has mastered the ability to travel through black holes? If such a species exists, they wouldn't be bound by the limits of normal space-time. They could move between galaxies in an instant, appearing and disappearing across the cosmos. If they were advanced enough, they might not even need planets anymore. They could build entire cities within the warp space of a black hole's event horizon, existing in ways we can't even comprehend. And if such civilizations exist, then could they have left clues behind? Could the strange signals we detect from deep space, things like fast radio bursts, FRBs, or unexplained gamma-ray bursts, actually be remnants of black hole-based technologies? Could the anomalies we observe in the cosmos be the fingerprints of civilizations that have already mastered black hole physics? If we ever want to find these civilizations, we might need to stop looking for planets and start looking at black holes instead. Because if there's one place in the universe where advanced beings might hide, it's in the depths of the most extreme and mysterious objects known to science. And what if our own future lies in black holes? If we ever reach a point where we can no longer survive on planets, whether due to natural disasters, cosmic events, or the inevitable death of our sun, then we might have no choice but to look toward black holes as our final refuge. Some scientists have even suggested that, in the far future, humanity could one day move into an artificial structure orbiting a black hole, harvesting its energy to sustain civilization for trillions of years. If this is true, then black holes might not just be the end of all things. They might also be the beginning of something entirely new. They might be the key to unlocking a future beyond our wildest imagination. And if that's the case, then maybe, just maybe, we aren't meant to fear black holes. Maybe we are meant to become them. Black holes have always been seen as the ultimate cosmic destroyers, monsters lurking in the depths of space, consuming anything unfortunate enough to cross their path. But what if we've been thinking about them all wrong? What if, instead of being forces of destruction, they are actually the key to understanding the deepest mysteries of the universe? What if they aren't just the end of matter, but the beginning of something entirely new? Let's step back for a moment. If black holes are capable of warping space and time so severely that nothing can escape, then what does that mean for the matter that falls into them? The common belief is that anything that crosses the event horizon is doomed. It spirals toward the singularity, where it's crushed into an infinitely small point. But modern physics suggests there might be more to the story. There's an idea known as conformal cyclic cosmology, proposed by the legendary physicist Roger Penrose. According to this theory, black holes might play a crucial role in the rebirth of the universe. Instead of being the final graveyards of matter, black holes could be cosmic seeds, places where information isn't lost, but instead transformed into the foundation for future universes. Think about it this way. If all matter in our universe eventually falls into black holes, and if black holes slowly evaporate over time through Hawking radiation, then what happens to everything they've consumed? Some physicists believe that, rather than simply vanishing, the energy and information inside black holes could be recycled. When the last black hole in our universe finally evaporates, trillions upon trillions of years from now, it might release all the information it ever consumed in a way that gives birth to a new universe. This means that black holes could be part of an eternal cycle, acting as the endpoints of old universes and the starting points of new ones. And if that's true, then the universe we live in right now might have been born from the remains of an ancient black hole that existed in a previous cosmos. But here's where things get even more mind-blowing. Some scientists have suggested that black holes might actually contain entire universes inside them. This idea is based on the fact that, from the perspective of an outside observer, anything falling into a black hole appears to slow down infinitely as it approaches the event horizon. This is due to extreme gravitational time dilation. Time slows down near a black hole relative to the outside universe. But what if, from the perspective of someone falling into the black hole, time doesn't stop? What if, instead of being crushed instantly, matter is actually spread out and reorganized inside the black hole in a way that resembles the birth of a new universe? Some physicists have speculated that our own universe could actually be the interior of a black hole that formed in a higher dimensional reality. If true, then every black hole in our universe might contain its own separate universe inside, an endless chain of nested realities. This would mean that black holes aren't just objects inside the universe. They might actually be universes themselves. Every time a new black hole forms, it could be the beginning of a brand new cosmos with its own space, time, and physics. And if that's the case, then our entire reality might exist inside a black hole right now, completely unaware of the larger reality that surrounds us. But let's take this one step further. If black holes can birth new universes, then is it possible for intelligent beings, perhaps even us, to create black holes as a way of seeding new universes? Some theories suggest that, in the distant future, an extremely advanced civilization could artificially create black holes in a controlled environment, setting the initial conditions to determine the physical laws of the resulting universe. This could allow for the deliberate design of new realities, tailored to sustain life in ways our own universe might not. If this is true, then the very laws of physics we take for granted, gravity, electromagnetism, the speed of light, could have been set by an ancient civilization that existed before our universe even began. What we think of as natural laws might actually be the result of intelligent design on a scale so vast that it's beyond human comprehension. And if that's the case, then who, or what, created the black hole that gave birth to our own universe? It's a question that pushes the limits of human understanding. But what we do know is that black holes aren't just dead ends in space. They are gateways to something far greater. They might be portals to other universes. They might be engines for civilizations far beyond our own. They might be the cosmic architects of reality itself. And if we ever hope to understand the true nature of existence, we can no longer afford to see black holes as monsters. Instead, we must recognize them for what they truly are, the greatest mysteries of the cosmos. Black holes have always been seen as cosmic enigmas. But what if they hold the key to an even greater mystery, one that could change our entire understanding of planetary formation? We typically think of planets as forming around stars, gathering from swirling disks of gas and dust that orbit newborn suns. But what if planets could form in the most unexpected places, around black holes? At first, the idea seems impossible. Black holes are often portrayed as destructive voids that tear apart anything that comes too close. Their immense gravity is known to rip apart stars and consume everything within their reach. So how could planets, delicate worlds that require stability, ever exist in such an environment? The answer might be more surprising than we think. Astrophysicists have proposed a fascinating possibility, that under the right conditions, planets could indeed form around black holes. This idea challenges everything we assume about planetary systems, but when we break it down, the physics actually supports the concept. Let's consider how planets form around regular stars. When a star is born, it emerges from a dense cloud of gas and dust. The leftover material flattens into a spinning protoplanetary disk, where gravity and collisions gradually lead to the formation of planets. But black holes, despite their reputation, can also have disks of material swirling around them, massive accretion disks made of gas and debris from objects that venture too close. These disks aren't just random collections of chaotic matter. They can have structure, much like the disks around young stars. Theoretically, if a black hole's accretion disk is stable enough and contains the right mix of elements, the same physics that forms planets around stars could take place around black holes. Tiny particles could stick together, forming larger and larger bodies until planets emerge from the chaos. But here's where things get truly mind-boggling. Unlike ordinary planetary systems, where planets orbit stars that shine brightly and provide energy, planets around black holes would exist in an environment of extreme radiation and gravitational forces. If these planets formed far enough away, beyond the reach of the black hole's intense gravitational pull, they could remain in stable orbits for millions or even billions of years. Some researchers suggest that planets in these black hole systems wouldn't be rare at all. They might actually be common. In fact, the galaxies we see today might be filled with black hole planetary systems that we simply haven't been able to detect yet. If black holes can sustain planetary formation, then the number of planets in the universe might be far greater than we ever imagined. But could these planets support life? That's where things get even stranger. Normally, planets rely on a star's heat and light to sustain biological processes. But in a system where a planet orbits a black hole, the conditions would be radically different. Instead of relying on starlight, a planet in a black hole system could receive heat from the cosmic radiation and gravitational forces at play. For example, if a planet were close enough to the accretion disk but still safely outside the event horizon, it could absorb energy from the surrounding matter. The extreme radiation from the disk could warm its surface, potentially making liquid water possible under the right circumstances. In theory, life could evolve in a way completely different from anything we know. Instead of depending on sunlight, it might rely on the energy emitted by the black hole's swirling disk. But that's not even the strangest part. There's a concept in physics known as Hawking radiation, which suggests that black holes slowly evaporate over time by emitting tiny amounts of energy. If a planet were orbiting a black hole that was small enough and radiating at the right rate, it could theoretically receive just enough warmth to sustain a stable climate. Imagine a world where the only source of heat comes from the black hole itself, where an entire ecosystem has adapted to exist in complete darkness, illuminated only by the faint, ghostly glow of Hawking radiation. If this sounds like pure science fiction, consider this: astronomers have already detected planets in places we once thought were impossible. We've found planets in the cold voids between stars, drifting alone in the darkness. We've discovered planets in extreme orbits around neutron stars, bombarded by deadly radiation yet still intact. If these extreme worlds can exist, why not planets around black holes? And if planets can form around black holes, then the implications are enormous. Could entire civilizations exist in these shadowy realms, hidden from view by the immense gravitational pull of the black holes they orbit? Could life have evolved in ways we've never even considered, thriving in conditions we once thought were uninhabitable? There's still so much we don't know. But one thing is clear: black holes aren't just voids of destruction. They might also be cradles of creation, places where the universe's strangest and most unexpected worlds take shape. The more we explore this idea, the more we realize that planets around black holes aren't just a theoretical curiosity. They could completely redefine what we consider a habitable world. If black hole planetary systems exist, they wouldn't just be exotic oddities. They could be everywhere, hiding in plain sight within the universe. One of the most exciting aspects of this concept is how these planets would form and evolve over time. If a massive accretion disk around a black hole can provide the right conditions for planet formation, then entire solar systems, or more accurately, black hole systems, could emerge from these swirling cosmic maelstrom. But these planetary systems wouldn't resemble anything we've seen before. In a typical solar system, planets orbit a star that emits a steady stream of light and energy. But in a black hole system, the main source of energy wouldn't come from the black hole itself, but from its accretion disk, a ring of gas, dust, and debris that glows intensely as it spirals inward. These disks can shine as brightly as entire galaxies, emitting massive amounts of radiation. If planets formed in the outer edges of these disks, far enough away to escape the extreme gravitational pull and deadly radiation near the event horizon, they could have a stable environment. But what would the conditions on these planets actually be like? It all depends on where in the system they form. If they are too close, they would be subjected to intense tidal forces, which could stretch and deform them, generating massive amounts of heat. This tidal heating could, in theory, create volcanically active worlds, similar to Jupiter's moon Io, where extreme geological activity is fueled by the constant gravitational tug-of-war between the planet and the black hole. On the other hand, if these planets formed further out, in a zone where the radiation from the accretion disk is less intense, they could have liquid water and stable atmospheres. Some scientists speculate that under the right conditions, a planet orbiting a black hole's accretion disk could sustain an atmosphere rich in organic molecules, possibly leading to the development of life. And here's where things get even more mind-blowing. What if intelligent life evolved in these black hole systems? Imagine a civilization that never saw a sun in the sky, only the glowing spiral of an accretion disk above them. Their concept of the universe would be entirely different from ours. They wouldn't know what a star is in the way we do. Their understanding of physics, energy, and time could be shaped by their unique environment. For them, black holes wouldn't be terrifying voids of destruction but rather the very source of life. But if planets can form around black holes, how could we ever detect them? Traditional methods of planet detection rely on observing stars, either by watching for the tiny dips in light when a planet passes in front of its star, the transit method, or by detecting the wobble caused by a planet's gravity pulling on its star, the radial velocity method. Since black holes don't emit light on their own, these methods wouldn't work. However, there's one promising approach: gravitational microlensing. This technique works by observing how massive objects bend and magnify the light of distant stars when they pass in front of them. If a planet orbits a black hole, its gravitational pull could subtly distort the light coming from behind it, creating a detectable signal. Scientists are already using microlensing to search for planets drifting through interstellar space, and with the right instruments, they might one day find planets orbiting black holes. And what about rogue planets? Worlds that once belonged to ordinary star systems but were ejected due to gravitational interactions. Could some of these planets end up orbiting black holes? The answer is yes. If a planet were flung into deep space but passed close enough to a black hole, it could be captured by its gravity and pulled into orbit. In this way, black holes could act as planetary collectors, gathering rogue planets that would otherwise be lost in the void. This raises another wild question. Could Earth itself one day orbit a black hole? While this sounds like the plot of a sci-fi movie, it's not entirely impossible. If the Sun were to die in a way that didn't destroy the solar system, and a rogue black hole passed close enough, its gravity could pull Earth into a new orbit. Our planet would be cast into darkness, forced to rely on geothermal energy, and whatever remaining heat it could absorb from the cosmic background radiation. Humanity, if it survived, would have to completely rethink how to generate energy and sustain life in a world without a sun. Of course, this is all speculation for now. But the more we study black holes, the more we realize that they are not just cosmic voids of destruction. They might be cradles of creation, harboring planets, perhaps even life, in ways we never imagined. If planets can form around black holes, what kinds of atmospheres would they have? Could they sustain breathable air? Would their skies be black, or would the glow from the accretion disk create an eerie, perpetual twilight? The answers depend on a complex interplay of factors, including radiation, gravity, and the composition of the planet itself. One of the biggest challenges for life on such a planet would be radiation. The accretion disk around a black hole emits intense X-rays and gamma rays, which can be lethal to life as we know it. If a planet were too close to the inner regions of the disk, it would be bombarded with high-energy particles, stripping away its atmosphere and sterilizing its surface. But if a planet formed further out, or if it had a strong magnetic field like Earth, it might be able to shield itself from the worst of the radiation. Another possibility is that life on such a planet could evolve to adapt to these extreme conditions. On Earth, we already have organisms known as extremophiles, life forms that thrive in boiling heat, crushing pressure, or extreme radiation. Perhaps alien life in a black hole system would develop radiation-resistant cells, or even harness high-energy radiation as a power source in ways we can't yet imagine. The sky on such a world would be unlike anything seen on Earth. Instead of a sun, the main source of light would be the accretion disk, a swirling, glowing ring of gas and dust spiraling toward the event horizon. The color of the sky would depend on the composition of the disk and the way light bends around the black hole. If gravitational lensing is strong enough, an observer standing on the surface might see a distorted, warped panorama, light from the accretion disk curving around the black hole, making it seem as if the glow surrounds them from all directions. Another bizarre effect would be time dilation. Close to a black hole, time moves slower due to the extreme warping of space-time. This means that if someone on Earth looked at a planet orbiting a black hole, they would see time passing much more slowly for any inhabitants there. If an astronaut lived on a planet in this system for a year, they might return to find that centuries had passed on Earth. This isn't just a theoretical idea, it's a direct consequence of Einstein's general relativity, and experiments with GPS satellites have already confirmed that time moves at different speeds depending on gravity. But could humans ever visit such a planet? The answer depends on the size and type of black hole. If it's a stellar mass black hole, the gravitational forces near the event horizon would be too extreme. Any spacecraft approaching would be spaghettified, stretched apart by tidal forces. But if it's a supermassive black hole, like the ones at the centers of galaxies, the tidal forces at the event horizon would be much weaker. A spacecraft could, in theory, get close enough to observe a planet in orbit without being torn apart. If advanced civilizations exist in black hole planetary systems, their technology would likely be unlike anything we've ever seen. Instead of relying on solar power, they might use the gravitational energy of the black hole itself, harnessing the immense forces at play. They could build Dyson spheres around the accretion disk to capture its radiation, or even extract energy from the rotational spin of the black hole through a process known as the Penrose mechanism. This raises another question: could we communicate with such civilizations? The extreme time dilation near a black hole would create a massive communication delay. If we sent a message, by the time we received a response, thousands of years might have passed for us, while only a few moments had gone by for them. This could mean that intelligent civilizations living around black holes experience time in a fundamentally different way. Perhaps to them, the rest of the universe seems to be moving at an impossible speed. And then there's the biggest mystery of all: have we already detected these planets without realizing it? Astronomers have discovered thousands of exoplanets using methods like the transit technique and radial velocity measurements. But black hole planets wouldn't produce the same signals as planets around stars. If they exist, they might be hidden among the many unexplained anomalies in our data, waiting for someone to recognize their true nature. If planets around black holes are real, they could redefine our understanding of how planetary systems form and survive. They would challenge our ideas about habitability, time, and even the fundamental nature of life itself. The universe is vast, and black holes are among the most common massive objects in existence. If even a small fraction of them host planets, there could be millions of worlds orbiting these cosmic giants, unseen and unknown, until now. The idea that planets might form around black holes is not just an abstract theory. It has real implications for our understanding of how gravity, matter, and time interact in extreme environments. If black hole planets exist, they would be some of the most alien and mysterious places in the universe, challenging our understanding of planetary formation and survival. One of the biggest questions about these planets is how they form in the first place. Around a normal star, planets form from the leftover gas and dust in a protoplanetary disk. But a black hole doesn't produce light or heat like a star does. Instead, it has an accretion disk, a swirling collection of superheated gas and matter that's slowly being pulled toward the event horizon. Could planets really form from this kind of chaotic environment? Some scientists believe the answer is yes. Studies have suggested that under the right conditions, the outer edges of a black hole's accretion disk might have enough cold, dense material for planet formation. The intense gravitational forces at play could cause dust and gas to clump together, forming planet-like structures over millions of years. In fact, researchers estimate that a supermassive black hole, like the one at the center of our galaxy, could host thousands of Earth-sized planets in its outer regions, orbiting in a vast, dark system unlike anything we've ever seen. But how stable would these planets be? Unlike planets orbiting a regular star, a planet around a black hole wouldn't experience a stable energy output. The accretion disk is a chaotic, unpredictable environment, with flaring jets of radiation and sudden bursts of energy. A planet would need to be far enough away to avoid being roasted by these emissions while still remaining gravitationally bound to the black hole. There's also the question of orbits. Normal planets orbit in predictable ellipses around their stars, but black hole planets might experience highly irregular, elongated orbits, affected by the massive gravity of the black hole and the motion of the surrounding accretion disk. Some planets might even have wildly unpredictable day-night cycles, depending on their distance and how light bends around the black hole's immense gravity. Another mind-bending concept is what would happen if a planet drifted too close to the event horizon. If it crossed the point of no return, it would be stretched and torn apart by tidal forces in a process called spaghettification. However, some theories suggest that certain stable orbits might exist within the gravitational pull of the black hole, allowing planets to exist for billions of years without falling in. But what about life? Could anything actually survive in such an extreme environment? The intense radiation near the black hole would make it difficult for Earth-like life to exist on the surface of a planet, but underground oceans, like those on Europa or Enceladus in our solar system, might provide a protective barrier against radiation. If a black hole planet had a thick atmosphere or was covered in deep oceans, it might create pockets of stability where life could evolve in ways we can't even imagine. Time itself would work differently for any inhabitants of a black hole planet. Due to gravitational time dilation, time moves slower near a black hole compared to the rest of the universe. This means that while only a few years might pass for someone living on the planet, millions of years could pass for outside observers. If an advanced civilization existed on one of these worlds, they might perceive the universe as speeding by at an unimaginable rate, stars being born and dying in what, to them, feels like moments. This leads to another fascinating question. Could intelligent life use black holes as a power source? Some physicists believe that advanced civilizations could harness energy from a black hole's rotation using a process known as the Penrose process, extracting energy from the black hole's ergosphere. Others suggest that a supermassive black hole's accretion disk could be used like a giant cosmic generator, providing power for an entire civilization. If alien civilizations have mastered this kind of technology, they might be hiding in plain sight, using black holes as energy sources or even as a means of interstellar travel. Some theories suggest that highly advanced beings could use black holes to manipulate gravity and time, bending the very fabric of space-time to their will. And then there's the possibility that we've already seen black hole planets without realizing it. Some unexplained anomalies in exoplanet data could hint at planets in unusual, highly gravitational environments. If astronomers refine their techniques and begin searching specifically for black hole planets, we might soon discover evidence of these strange, hidden worlds. The existence of planets around black holes would challenge everything we thought we knew about planetary systems. It would prove that life and matter can form in even the most extreme conditions, and it might open the door to new discoveries about gravity, time, and the nature of the universe itself. If black hole planets exist, they wouldn't just change our understanding of planetary formation, they would redefine the very nature of what it means to be a habitable world. In our current understanding, habitable planets must orbit within a star's Goldilocks zone, the region where conditions are just right for liquid water to exist. But around a black hole, there is no traditional warmth from a star, no steady sunlight to nourish life. Instead, the main sources of energy would be the accretion disk, the black hole's jets, and gravitational interactions. This leads to a wild but serious question. Could a black hole provide enough energy for life to exist on a planet orbiting it? At first, the idea seems absurd. A black hole is a dead star, a void where light itself is trapped. But surprisingly, it might not be as barren as it seems. One possible scenario involves a planet orbiting in a stable, distant region of the accretion disk, far from the black hole's deadly event horizon. The accretion disk, the swirling ring of matter falling into the black hole, releases intense radiation. If a planet is at the right distance, it could absorb enough heat and energy to sustain a stable climate. Instead of relying on a star for light, the planet could be warmed by the searing glow of the superheated gas swirling around the black hole. This concept isn't just theoretical. In 2019, researchers at Kagoshima University in Japan ran simulations and found that a supermassive black hole, surrounded by a dense accretion disk, could theoretically host dozens of Earth-like planets. These planets wouldn't get energy from a star, but from the thermal radiation emitted by the hot, swirling gas around the black hole. In other words, the accretion disk itself could act like a pseudo-sun, creating a new kind of habitable zone. However, living near a black hole comes with extreme risks. The radiation levels from the accretion disk would be much higher than what we experience on Earth. Any potential lifeforms on these planets would need to develop extreme resistance to radiation, or they might survive underground, beneath thick layers of ice or rock that could shield them from the worst of the radiation. Another possible energy source comes from the Hawking radiation emitted by the black hole itself. According to physicist Stephen Hawking's theory, black holes aren't completely black. They slowly release small amounts of radiation over time. While Hawking radiation is usually too weak to affect anything on a human scale, around a tiny, primordial black hole, the effect might be much stronger. If a small black hole existed near a planet, it could theoretically provide a continuous source of heat and energy, like a tiny cosmic furnace. But what about the sheer gravitational forces at play? Black holes are notorious for their intense tidal forces, capable of ripping apart entire stars. Could a planet really remain intact in such an environment? The answer depends on how close the planet orbits. If it's too close, the extreme gravitational pull would create violent tidal forces, stretching the planet like taffy in a process called spaghettification. But at a safe distance, perhaps orbiting a supermassive black hole rather than a smaller, more chaotic one, a planet could potentially survive for billions of years without being torn apart. In some cases, planets might form from the debris of destroyed worlds. If a star wanders too close to a black hole, it gets torn apart by tidal forces, leaving behind massive clouds of gas and dust. Over time, these materials could clump together to form new planets, meaning that black hole planetary systems might be built from the remains of other worlds. One of the biggest challenges in proving the existence of black hole planets is that they would be nearly impossible to detect with traditional methods. When we search for exoplanets around stars, we usually look for tiny dips in brightness as the planet passes in front of its star. But around a black hole, there's no steady source of light to measure. Instead, scientists would need to search for gravitational effects, looking for how an unseen planet might tug on the surrounding matter. One way we might detect black hole planets is through gravitational microlensing, a method that looks for how a planet's gravity bends and distorts the light from distant background stars. If a planet orbits a black hole, its gravity might create tiny wobbles in the way light passes around the system, giving astronomers a way to infer its presence. Another possibility is that we've already detected black hole planets without realizing it. Some unexplained anomalies in Kepler telescope data could hint at planets orbiting objects we didn't previously consider. If astronomers take a closer look at these strange signals, they might find the first evidence of planets in the darkest corners of the universe. There's even a possibility that a rogue planet, one that was ejected from its original solar system, could get trapped in orbit around a black hole. Some simulations suggest that billions of these free-floating planets might exist in the galaxy, wandering alone through space. If one of these rogue planets drifted close to a black hole, it could become gravitationally captured, settling into a stable orbit, and creating a dark planetary system unlike anything we've ever seen. And if planets can exist around black holes, what about moons? If a large planet orbits a black hole, it might have its own system of moons circling it. These moons, sometimes called exomoons, could experience wild gravitational forces, leading to intense volcanic activity, deep underground oceans, and extreme climate shifts. Some scientists believe that these black hole moons might actually be more habitable than the planets themselves, since the tidal forces from their parent planet could generate internal heat, keeping their subsurface oceans liquid. If we ever find planets around black holes, it would force us to rethink our definition of what makes a world habitable. Life, if it exists in these strange environments, might look completely alien, adapted to survive in conditions that seem impossible by Earth's standards. Instead of relying on sunlight, these life forms might get their energy from thermal radiation, gravitational heating, or even exotic unknown forces. The discovery of black hole planets would also raise profound philosophical questions. If civilizations evolved in these extreme environments, their perception of time would be drastically different from ours. Due to gravitational time dilation, time moves slower near a black hole. A single year for them could mean millions of years have passed for us. If an intelligent species lived near a black hole, they might witness entire eras of the universe unfolding in what feels like a single lifetime. This raises the possibility that advanced civilizations could be intentionally hiding near black holes. If a civilization wanted to avoid detection, a black hole system would be the perfect place to remain unseen. The immense gravitational pull would bend and distort light, making it nearly impossible to spot them from Earth. Some have even speculated that highly advanced beings could be using black holes as energy sources, time manipulation devices, or even as gateways to other dimensions. Could we one day travel to a black hole planet? The idea might sound like science fiction, but as our technology advances, it's not entirely impossible. If we develop spacecraft capable of withstanding extreme gravitational forces, we might one day send probes, or even humans, to explore these dark, alien worlds. The data we gather could revolutionize our understanding of the universe and might even provide clues about how black holes themselves work. Ultimately, the existence of planets around black holes would be one of the greatest discoveries in astrophysics. It would prove that the universe is far stranger and more complex than we ever imagined. And if life exists on these worlds, it could challenge everything we thought we knew about the conditions necessary for survival. If planets can orbit black holes, what does that mean for the broader understanding of planetary formation? Traditionally, we assume planets form around stars, where dust and gas coalesce into rocky or gaseous bodies over millions of years. But a planet orbiting a black hole suggests that planets can form or survive in environments far beyond what we previously believed. One possibility is that these planets were originally formed in a standard solar system but were later captured by a black hole's gravity. If a star system drifted too close to a supermassive black hole, the star itself might be torn apart, but some of its planets could be flung into stable orbits around the black hole. This would mean that some black hole planets could be ancient survivors, worlds that once orbited a normal sun but were later trapped in an eternal orbit around darkness. Another possibility is that planets could form from the debris of destroyed stars. When a star gets torn apart by a black hole, the immense gravitational forces rip it into streams of gas and dust. Over time, this material could clump together, forming entirely new planets in the shadow of the black hole. This would suggest that planetary systems can emerge even in the most extreme environments, meaning there may be countless hidden worlds orbiting the supermassive black holes at the centers of galaxies. But how would time work on these planets? One of the strangest effects of black holes is gravitational time dilation, a consequence of Einstein's theory of relativity. The stronger the gravitational field, the slower time moves relative to an observer further away. If a planet orbits close to a black hole, time for inhabitants on that world could be moving much slower than it does for the rest of the universe. Imagine a planet where 1 year feels like 1,000 years elsewhere in the universe. A civilization living on such a world would perceive time very differently from us. If they tried to communicate with us, our responses might seem to arrive at impossibly fast speeds, while their responses would appear agonizingly slow to us. If a spacecraft from Earth visited such a planet and spent just a few years there, it could return to find millions of years had passed on Earth. This raises an eerie question: could ancient alien civilizations exist near black holes, living in a vastly different flow of time from the rest of the universe? If an advanced species settled around a black hole billions of years ago, their civilization might still be in its early stages by their perception, while the rest of the universe has aged dramatically. In effect, a black hole could act as a natural time capsule, preserving civilizations in a slowed-down pocket of reality. Some have even speculated that black holes might be ideal hiding places for advanced extraterrestrial civilizations. The immense gravitational pull of a black hole bends and distorts light, making it incredibly difficult to detect anything near it. If a civilization wanted to remain invisible to the rest of the cosmos, settling near a black hole would be one of the best ways to do it. But let's take this idea further. What if intelligent life forms evolved directly on a planet orbiting a black hole? Would their perception of reality be entirely different from ours? With no sun in their sky, they would never know what a day, or night, is in the way we do. Their world might be permanently illuminated by the accretion disk, or it might be bathed in near total darkness. If they have evolved biological adaptations to survive extreme radiation, their physiology could be completely alien compared to Earth-based life. The most extreme scenario would be a planet orbiting deep within a black hole's photon sphere, the region where light itself can orbit the black hole indefinitely. A planet in this zone would experience insane gravitational distortions, where light could wrap around the black hole multiple times before reaching the surface. This means that an observer on the planet might see multiple versions of the same star or galaxy in the sky, appearing in different places at once due to the gravitational bending of light. And what about black holes themselves? Some physicists believe that inside a black hole, the laws of physics as we know them break down. If planets can exist around black holes, could they exist inside one? The idea seems impossible, since the intense gravitational forces inside a black hole should crush anything into oblivion. But if black holes contain hidden layers of reality, as some speculative theories suggest, then it's possible that an entire universe could exist within a black hole. This leads to the black hole cosmology hypothesis, which suggests that our own universe might be inside a black hole. If this is true, then every black hole in our universe could be the gateway to another universe, where time and space unfold in ways we can't even imagine. If this is true, then planets orbiting black holes could be positioned at the very edge of reality itself, existing in a liminal space between one universe and another. One of the most exciting ideas is that, if planets can orbit black holes, it might be possible to harvest energy from the black hole itself. The immense rotational energy of a spinning black hole could, in theory, be extracted using a concept called the Penrose process. If an advanced civilization built orbiting structures around the black hole, they could tap into this energy and power entire planetary systems. If this is possible, then black holes wouldn't just be cosmic voids, they could be power sources for civilizations far beyond our comprehension. Some physicists have even suggested that if we ever encounter an advanced alien species, they might not be living near stars, they might be harnessing energy from black holes instead. Could we ever travel to a black hole planet? Theoretically, yes, but only with extremely advanced technology. Any spacecraft attempting to approach a black hole must be able to withstand immense gravitational forces, high-energy radiation, and extreme time dilation effects. A probe sent to a black hole planet might experience hours or days passing on board, while centuries pass back on Earth. This means that any real attempt to explore these worlds would require a deep understanding of relativity and time manipulation. Some have proposed that future civilizations could use black holes as gateways for interstellar travel. If we could somehow manipulate spacetime near a black hole, we might be able to bend reality itself, creating shortcuts through the fabric of the universe. If an advanced species has already mastered this, then black holes might not just be deadly voids, they could be portals to destinations across the cosmos. Ultimately, the existence of planets orbiting black holes rewrites everything we thought we knew about planetary science, habitability, and even the nature of the universe itself. If we find one, it would be one of the most profound discoveries in the history of astronomy. It would prove that life can exist in places we once thought impossible, and that black holes, traditionally seen as cosmic destroyers, could actually be creators of new worlds. And if we find planets around black holes, who knows what else might be lurking in the darkness? If planets can exist around black holes, could entire planetary systems form in these extreme environments? A traditional solar system forms when a cloud of gas and dust collapses under gravity, creating a central star and a disk of material that eventually forms planets. But what if the same process could happen around a supermassive black hole instead of a star? Recent simulations suggest that disks of material around black holes could be dense enough to form planets. In the heart of many galaxies, vast amounts of gas, dust, and debris swirl around supermassive black holes in what's known as an accretion disk. Some researchers believe that, under the right conditions, this material could cool, clump together, and form planets in a process similar to regular planetary formation. This means that there could be entire planetary systems orbiting black holes, with multiple worlds caught in the gravitational grip of the darkness. These systems could be wildly different from what we see in regular star systems. Instead of orbiting a shining sun, they would orbit an invisible force, bathed in the strange, ghostly light of the accretion disk. But could life actually exist on one of these planets? It depends on whether such a world could get enough energy to sustain life. A black hole itself doesn't produce light like a star, but the material in the accretion disk can become superheated as it spirals inward, emitting intense radiation. Some of these black hole planets might be tidally locked, meaning that one side always faces the accretion disk while the other remains in perpetual darkness. If so, the habitable zone might exist in the twilight region between the two extremes, where temperatures are stable enough to support life. However, life near a black hole would have to survive intense radiation, including high-energy X-rays and gamma rays. If a planet had a thick atmosphere or strong magnetic field, it might be able to shield itself from the worst of this radiation. Life forms on such a world would likely evolve extreme adaptations, potentially leading to radically different biochemistry compared to Earth-based life. And what about civilizations? If intelligent beings developed on a black hole planet, their understanding of physics and time would be completely different from ours. They would experience reality through the lens of extreme time dilation. If they looked up at the stars, they might see the universe moving at incredible speeds, with stars forming, exploding, and vanishing in what, to them, would feel like mere moments. If such a civilization developed advanced technology, they might harness the energy of the black hole itself. One possibility is the Blandford's-Nagic process, which suggests that the rotational energy of a black hole could be extracted through magnetic fields. An advanced species could build structures in orbit around the black hole to siphon off this energy, powering their entire civilization with the gravitational might of the cosmos. Some theories even suggest that black holes could be used as computing devices, with information stored on the event horizon in ways that transcend our current understanding of physics. If this is true, then an advanced civilization near a black hole might use it as a natural megastructure, transforming it into an enormous cosmic supercomputer capable of processing data on an unimaginable scale. If we ever detected such a civilization, how would we communicate with them? The problem of time dilation would make traditional communication almost impossible. If we sent a message to them, it might take centuries or millennia for them to respond, even if they replied immediately by their own perception of time. But what if we already have signals from civilizations near black holes and don't recognize them? If an alien species near a black hole has tried to communicate with us, their signals might be highly distorted by relativistic effects, making them seem like nothing more than background noise. The very nature of black holes makes them ideal cosmic hiding places. A civilization that wanted to avoid detection could situate itself near a black hole, where light is warped and signals are difficult to distinguish from the surrounding cosmic radiation. Could it be that the most advanced species in the universe have already discovered this and are hiding in the shadows of these immense gravitational wells? But if civilizations can thrive around black holes, what about the possibility of travel through them? While traditional physics suggests that falling into a black hole results in destruction, some speculative theories propose that black holes could be gateways to other parts of the universe, or even other universes. One of the most famous ideas is the Einstein-Rosen bridge, better known as a wormhole. If some black holes contain shortcuts through spacetime, an advanced species might use them as a means of interstellar travel. Instead of using traditional spacecraft, they might develop ways to manipulate gravity itself, effectively bending reality to their will. But could we ever travel to a black hole planet? The biggest challenge would be the gravitational forces at play. Any spacecraft attempting to approach a black hole would have to deal with immense tidal forces, where different parts of the ship could experience dramatically different gravitational pulls, potentially tearing it apart. Additionally, The extreme time dilation means that anyone who visited a black hole planet and returned to Earth would find that centuries or millennia had passed. This creates a paradox. If we colonized a black hole world, it might still feel like the early days of exploration for the settlers, while the rest of the universe moved on without them. And then there's the biggest question of all: what's inside a black hole? If planets can orbit black holes, could they exist inside them? Theoretically, once something crosses the event horizon, it should be pulled toward this singularity and crushed. But some theories suggest that black holes could contain entire hidden universes, where the normal rules of physics break down. If this is true, then entering a black hole might not mean destruction. It might mean being transported to an entirely different realm of existence. Could black hole planets act as gateways to other dimensions, serving as the last outpost before entering a new universe? And if so, could there be civilizations out there who have already mastered this knowledge, who have learned to navigate between universes using black holes as cosmic doorways? If such beings exist, they might not be limited to a single reality, but could move between different layers of existence, shaping the cosmos in ways we can't even comprehend. If planets can orbit black holes, then the universe is far stranger than we ever imagined. It suggests that life in planetary systems are not limited to the warm glow of stars but can exist even in the deepest, darkest places in the cosmos. And if life can thrive around black holes, what else is out there, waiting for us to find it? If black holes can host entire planetary systems, what does this mean for our understanding of planetary formation and cosmic habitability? Until recently, we assumed that planets needed to form around stars, receiving warmth and energy from their parent sun. But if planets can exist around black holes, then stellar light is not the only requirement for planetary habitability. This raises the question: how common are black hole planets? If we consider the sheer number of black holes in the universe, ranging from stellar mass black holes formed from supernovae to supermassive black holes at the centers of galaxies, there could be trillions of black hole planets, hidden in the shadows of the cosmos. But how would we find them? Black hole planets wouldn't be visible like normal exoplanets. Instead of reflecting starlight, they would be bathed in the eerie glow of an accretion disk or shrouded in perpetual darkness. Their discovery would require detecting subtle gravitational effects, such as microlensing, where a black hole and its planets bend light from a background star. If a planet orbits a black hole in just the right way, its gravitational influence could cause periodic distortions in the light we see, revealing its presence. However, such detections would be incredibly rare, making black hole planets some of the most elusive objects in the universe. But what if we've already observed black hole planets without realizing it? There are mysterious signals in space, unexplained dips in brightness from distant objects, unusual radio emissions, and gravitational anomalies that could be evidence of unknown planetary systems orbiting black holes. And if planets can form in the extreme conditions around the black hole, could moons form as well? In our solar system, moons like Europa and Titan suggest that habitability is not limited to planets alone. A large black hole planet could have multiple moons, each with its own conditions, atmospheres, and potential for life. Some moons might have thick atmospheres shielding them from radiation, while others could have vast underground oceans, heated by tidal forces from the gravitational interactions with the black hole. If life developed on one of these moons, it could have a completely different evolutionary path, thriving in a world where day and night are meaningless, and where the most significant source of energy comes from the radiation of a distant, glowing accretion disk. But what happens to these planets over time? Black holes don't last forever. If a black hole planet orbits a supermassive black hole in a galactic center, it might be stable for billions of years. However, if a planet orbits a smaller, stellar mass black hole, it faces a more uncertain fate. If the black hole feeds on surrounding material, growing larger, it could eventually enter a phase where it consumes everything nearby, pulling planets and moons into its event horizon. Alternatively, if the black hole is left without material to consume, it could slowly evaporate over trillions of years through Hawking radiation. In this scenario, any planets that once orbited it would eventually be set adrift, becoming rogue planets wandering the cosmos. And what about binary black holes? Could two black holes orbiting each other create even more complex planetary systems? If a planet orbited a pair of merging black holes, it would experience some of the most extreme gravitational distortions imaginable. As the black holes spiral toward each other, their intense gravitational waves could disrupt planetary orbits, causing some planets to be flung into deep space, while others are torn apart. If a civilization developed near a black hole, they would need to master gravitational mechanics on an entirely new level just to survive. Their entire world would be shaped by forces beyond our comprehension, time moving at different rates, intense radiation exposure, and gravitational shifts that could stretch and bend everything they perceive. Would such beings even resemble life as we know it? If life evolved under such extreme conditions, it might be unrecognizable to us, possibly incorporating exotic biochemistry, or even utilizing the strange properties of space-time itself. And what if some of these civilizations discovered ways to manipulate black holes? Could they build Dyson spheres around black holes, harnessing their immense energy? Could they construct artificial event horizons, using black hole physics to power their technologies? One of the most mind-bending possibilities is that advanced civilizations might intentionally migrate to black holes to extend their lifespans. Since time dilation near a black hole slows time relative to the outside universe, a civilization that settled close enough to a black hole's event horizon could experience millennia of subjective time, while only centuries pass elsewhere in the cosmos. If this is the case, the most advanced beings in the universe might not be out there among the stars at all. They might be hiding near black holes, existing in a vastly different time frame than the rest of us, watching the universe unfold in slow motion. Could we ever reach such a civilization? Could they even communicate with us in a meaningful way? If we sent a message toward a civilization near a black hole, our words might take thousands of years to reach them, and by the time they responded, our civilization might be long gone. But if they have technology capable of manipulating gravity itself, they might not be limited by these constraints. They might have found ways to bypass time dilation, using black holes as portals not just through space but through time. And if this is true, then black holes may not be just the end of stars. They may be the beginning of something far greater, a gateway to realms of existence that we have yet to understand. If black holes are home to planets, to civilizations, to entire ecosystems existing in defiance of everything we thought we knew, then the universe is far stranger than we ever imagined. What other secrets are hiding in the depths of these cosmic voids, waiting for us to uncover them? The idea that entire planetary systems could exist around black holes forces us to reconsider the fundamental rules of planetary formation and habitability. We have long assumed that planets require a star to provide light and heat, but black hole planets defy this assumption entirely. Instead of basking in the glow of a sun, these worlds could be illuminated by the haunting radiance of an accretion disk or, in some cases, remain shrouded in total darkness. The implications of this are staggering. If planets can exist in such extreme environments, how many might be out there, lurking unseen in the gravitational grip of a black hole? To detect such planets, we would need to look for unconventional signs. Traditional exoplanet detection methods, such as the transit method, which observes dips in a star's brightness as a planet passes in front of it, would be useless in the case of a black hole. Instead, astronomers would have to rely on more indirect means, such as gravitational microlensing. This occurs when the intense gravity of a black hole bends the light from a distant background star, temporarily magnifying it. If a planet orbits the black hole, it could cause a second, smaller distortion in the magnified light, betraying its presence. While such events are rare and difficult to observe, they provide one of the few ways we could confirm the existence of black hole planets. Another potential detection method involves searching for unusual radiation signatures. If a planet orbits within the accretion disk of a black hole, it might interact with the disk's intense energy fields, producing electromagnetic signals that we could detect. These signals would be unlike anything we've seen from conventional planets, adding yet another layer of mystery to these potential worlds. But let's take this idea even further. If planets can form around black holes, could they also have moons? In our solar system, many moons, such as Europa and Titan, are considered prime candidates for extraterrestrial life. A moon orbiting a black hole planet might experience intense tidal heating, similar to how Jupiter's gravity causes Io's volcanic activity. This could create underground oceans of liquid water, hidden beneath thick layers of ice, making them potential habitats for life. The nature of time itself would also be profoundly different near a black hole. Due to the effects of gravitational time dilation, time on a planet close to a black hole would pass much more slowly relative to the rest of the universe. If intelligent life evolved on such a planet, its perception of time could be vastly different from our own. A single second for them might equate to years or even centuries in the rest of the cosmos. If an advanced civilization existed in such a region, how would they perceive the universe beyond their gravitational well? Would they see distant stars evolving at an impossibly fast rate, entire civilizations rising and falling in what feels like the blink of an eye? Even more intriguingly, could such a civilization use black hole physics to their advantage? If they understood how to manipulate space-time, they might develop technology far beyond our comprehension. Some theories even suggest that black holes could serve as gateways to other universes or alternate dimensions. Could a sufficiently advanced civilization harness these properties to escape the confines of their black hole's gravitational pull? Could they travel to places in the cosmos that we cannot yet imagine? One of the most astonishing possibilities is that black holes themselves might serve as artificial constructs, vast megastructures built by an ancient and unfathomably advanced civilization. If a civilization were able to control black holes, they could use them as nearly limitless sources of energy, feeding matter into them to extract power through Hawking radiation. A Dyson sphere, a hypothetical structure designed to harness all of a star's energy, would be nearly impossible to build around a conventional star, but around a black hole, such a structure might be feasible. Instead of capturing sunlight, it would capture the immense radiation emitted by the accretion disk and relativistic jets. If civilizations exist near black holes, we might already be detecting their activities without realizing it. Some unexplained astrophysical phenomena, such as ultra-high-energy cosmic rays or fast radio bursts, could potentially be the signatures of advanced extraterrestrial technology operating near black holes. If we ever find evidence of artificial structures orbiting a black hole, it would be the ultimate confirmation that intelligent life is not only out there but is capable of manipulating the most extreme objects in the universe. Even more unsettling is the possibility that some of the black holes we observe are not entirely natural. What if some of them were created intentionally? If a sufficiently advanced civilization needed to store vast amounts of information or energy, a black hole could serve as the perfect data repository or energy source. In a way, black holes could be cosmic hard drives, storing information in a way that we are only just beginning to understand. The idea of planets forming around black holes opens the door to so many possibilities that it challenges the very foundation of what we thought we knew about the universe. If black holes can host planets, then entire hidden ecosystems could exist in the shadows of the cosmos, unseen and unsuspected. These planets might be home to life forms unlike anything we can imagine, creatures adapted to a world without sunlight, feeding off the faint radiation of an accretion disk, or the heat from tidal forces. Could such a world exist in our own galaxy? If so, where would we find it? The Milky Way is home to an estimated 100 million black holes, many of which remain undetected. If even a small fraction of these black holes have planets, the number of potential habitable worlds could be enormous. And if some of these planets are in stable orbits around supermassive black holes, they could exist for billions of years, providing ample time for life to evolve and civilizations to rise. If we one day develop the ability to travel to a black hole system, what would we find? Would we discover desolate, radiation-scorched worlds orbiting in eerie silence? Or would we find thriving ecosystems built on the energy of the black hole itself? Could we encounter beings that have transcended the constraints of time, existing in a realm where the past, present, and future blend together? The search for black hole planets is not just a search for new worlds, it is a search for new possibilities, for new definitions of life, and for answers to the deepest questions about the nature of the universe itself. And if we find them, it will not only change our understanding of planetary science, it will change everything we know about existence. If black hole planets exist, they could be some of the most extreme and bizarre worlds in the universe. Unlike planets orbiting normal stars, these worlds would be bathed in an eerie glow from the accretion disk, which could range from blindingly bright to nearly pitch black depending on the activity of the black hole. The atmosphere, if one existed, would be bombarded by high-energy radiation from the accretion disk and relativistic jets, potentially stripping away lighter gases and leaving behind a thick, crushing atmosphere of heavier elements. But what about the surfaces of these planets? If a black hole planet were tidally locked, meaning one side always faced the black hole, it could create an environment with drastic temperature contrasts. The side facing the accretion disk might be scorching hot, while the dark side could be frozen solid. In such an environment, the only habitable region might be a thin band between the two extremes, a twilight zone where temperatures could be moderate enough for liquid water to exist. On the other hand, some black hole planets could be rogue worlds, planets that were ejected from their original solar systems and later captured by the gravity of a black hole. These planets might have formed around a star billions of years ago, only to be flung into the interstellar void before settling into a stable orbit around a black hole. If these planets retained a thick atmosphere or subsurface oceans, they could provide conditions for life even without sunlight. One of the most fascinating implications of black hole planets is how time would behave on their surfaces. General relativity tells us that time slows down near a massive gravitational source. A planet orbiting close to a black hole, though still outside the event horizon, would experience extreme time dilation. This means that while only a few years might pass for someone on the planet, thousands, or even millions of years could pass for an observer in deep space. This raises the question, what would intelligent life be like on such a world? If an advanced civilization evolved on a black hole planet, they might experience time so differently that their entire history could unfold in what, to us, would be a fraction of a second. Conversely, if we visited such a world, we might perceive the universe outside as moving at an impossible speed, with stars aging and dying before our eyes. Would life forms on a black hole planet be aware of this time distortion? Would they have ways to communicate with the outside universe, or would they exist in total isolation, trapped in a reality where the passage of time is fundamentally different? If they did develop advanced technology, they might use it to escape the black hole's gravitational influence, or, more incredibly, to manipulate time itself. A civilization that mastered time dilation could effectively control its own evolution. By living near a black hole, they could stretch their existence across eons while the rest of the universe ages rapidly. This could allow them to outlast other civilizations, watching from the depths of time as empires rise and fall in the blink of an eye. But what if they could go even further? Some physicists speculate that black holes might connect to other parts of the universe through wormholes or Einstein-Rosen bridges. If a highly advanced civilization found a way to stabilize such a passage, they might use it to travel vast cosmic distances instantaneously. Could black holes be intergalactic highways used by civilizations far older than our own? Even more intriguingly, could some black holes be artificial? If a civilization reached a level of technological mastery far beyond our comprehension, they might create black holes as energy sources, time vaults, or even as mechanisms for interdimensional travel. Some theories suggest that the immense energy output of black holes could be harnessed through a concept known as the Penrose process, in which matter falling into a rotating black hole releases enormous amounts of energy. If black holes are more than just natural remnants of dead stars, if they are, in some cases, cosmic engineering projects, then we must rethink everything we know about the universe. Could some of the black holes we observe be machines, constructed by an ancient intelligence beyond anything we can imagine? The implications of black hole planets go beyond just astronomy. They challenge our understanding of reality itself. If life can exist in the gravitational grip of a black hole, then life is far more adaptable than we ever imagined. If civilizations can manipulate black holes, then our place in the cosmos is far more insignificant than we ever realized. And if black holes are artificial, then the universe may be far more complex, structured, and intentional than we dare to believe. Somewhere out there, in the cold, dark regions of space, a planet may be orbiting a black hole, its surface bathed in the eerie glow of an accretion disk. Perhaps life has evolved there, adapted to the crushing gravity, the warped passage of time, and the extreme conditions of such a world. Perhaps entire civilizations have risen and fallen in the time it takes us to blink. Or perhaps, even now, as we peer into the cosmos, they are watching us, moving through time at a speed we cannot comprehend, waiting for the moment when they will finally reveal themselves. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.